E agora eu vou abrir para o público começar a entrar, tá bom? Quando tiver um número razoável, vocês arrancam, tá
Ok.
bom? Tá, então vou abrir agora. Agora já começou.
Good morning, all. Welcome to this scientific workshop. We're just going to wait another couple of minutes so we get a little bit more people, and we'll start. Okay, good morning. Welcome again. We already have now more than 30 participants watching, so we can surely start our scientific workshop for EOatSEE. So I will share a presentation, do a quick introduction before we start the technical session. So, like I said, I will start by providing a brief project overview so we understand the context before we start the technical scientific session. So, Earth Observations Advanced Tools for Sea Level Stream Events. It's a project funded by ESA through the call named Sea Level and Coastal Hazards. And it is now a project, a 2-year project, which is being led by Demos, and it's is being developed by this set of partners that you can see in the screens. And of course, all partners are participating in all 5 phases of the project, but we are trying here to showcase a bit of the roles of each of these partners. So we have Demos doing management and integration and production of this data set. So basically providing the infrastructure for development of these tools. Then we have Plus Atlantic doing the scientific lead of the project. So conducting all the scientific work and guiding us through this project in terms of scientific challenges that are to be addressed. And we have the Air Center doing the dissemination and communication part of the project, which of course, this workshop that we are today is part of this job. Then we have a set of very renowned companies and institutions doing the numerical modeling and also working in the science cases. So we have Deltares, we have CMCC, and we have University of Bologna, and all, of course, working jointly with Plus Atlantic to develop the scientific work. And on the other side, we have also companies from the Earth Observation Community, so providing a lot of these tools, data sets, and solutions and that we are going to be working and using in the project. So the main objective of EOatSEE is to provide a reconstruction of the relevant process on extreme sea level events. And this should be a data-driven reconstruction and both in the short-term and long-term scales. And the idea is to use this reconstruction to improve the scientific understanding and the predictive capacity of such events. So by addressing key topics, key scientific challenges that we are going to present today. And finally, we want to transfer these results to society so we can have a better preparation of these coastal communities for the impacts and risks associated with these extreme events. And of course, all of this is done through a community effort. So, which again, this scientific workshop that we're having today is a good example of that. We want to interact with the best experts in the field and try to get the most out of this effort. Here is a summarized timeline of the project, so you can understand a little bit how it's being conducted. So the project started just a couple of months ago on June this year, and we are just finishing now this first phase of scientific requirement consolidation. And as you can see, we are here today for the scientific requirement workshop to consolidate what has been investigated mostly by Plus Atlantic, but also with the participation of all partners. We did a literature review. We also had different workshops to define the scientific challenge and also to review the state of the art of Earth observation in the field. At the same time, in parallel, we are already providing building a catalog of these data sets and tools that are going to be used in the project so we can start data collection. And the next phase, we are going to the implementation and validation phase, which is actually the development of these algorithms, the implementation of these tools in the locations that we need the data to be produced. And of course, the tests and validations that we need for that to make sure that we have reasonably good results. The next phase then, which will actually start in 3 months, will be the production phase. So the generation of these data sets, the generation of such products, such outputs that we will need to perform the scientific analysis. And this will take another 6 months, which will partially overlap with the development phase. And it will be mostly performed over cloud infrastructures. So using Earth observation exploitation platform and trying to have everything in a way that is readily reusable and scalable for other projects, for other stakeholders that get interested. Because of course, the main output of this phase is the extremely experimental data set generate data sets, which of course is the so-called data-driven reconstruction of these extreme events, both in the short-term and long-term approaches. And once we have this data set, we will promote another scientific workshop, this time to look at the roadmap. So to look at what lies ahead of us, not only in terms of the scientific work to be done within the project, but also to the new tools and solutions that are still needed, and the additional work that should be done after the project ends in a 5-year horizon. And again, we will count with the community here to bring we all together and to show these results and open for criticisms and suggestions of the community. The next phase, the second year of the project, then will be the scientific part. So where we'll address all the scientific cases that will be shown later today. And of course, this will result in several peer-reviewed publications. And again, we foster the collaboration with the community. So we are already engaging with a set of scientific experts. Not only some of them are present here today, but also others that are, for instance, involved in the production of some of the data sets that we consider the state of the art and that are to be used in the project. So we hope that we can interact with them and generate the best possible scientific work to advance our knowledge on these extreme events. And at the same time, we want to also transfer these results to society. So this is going to be done mostly through a geo portal where we will be exposing all these results from the project, also validation analysis reports, and this will be delivered to a set of early adopters that we already have engaged from the start for each of the use cases that we have in the project. Of course, the project will end in 2024, where all of these results will be available for the community to explore and, of course, to further develop this work. The logic of this project is based, like I said before, we have 2 different approaches in the project. We are trying to approach extreme events both from the short term and from the long term perspective. So everything starts with the development and the identification of these advanced science tools and data sets, which in the case of short terms are basically numerical models that we already have implemented for different use cases, but also a set of innovative, the latest available EO data sets that we can use. With this, we will be able to build very short time series with very high resolution and to have a very good, let's say, approach for the short term and evaluate the capacity of these Earth observation tools to improve our understanding of these events in the short term or representation of these events. We'll do this extreme event analysis in the short term, but also on the long term, we will use reduced complexity models to try to simulate this for an horizon of 20 years, try to simulate this occurrence of this several of these events and how they will the effects they will have on the coast. And for those, we of course will build this time series using this simplified reduced complexity models. We will also build different indexes, which will be explained a little bit better after today. And of course, we will then try to do a historical extreme event analysis and also provide some analysis regarding the historical trends, but also provide some future scenarios, some adapting these new results to of course, the IPCC scenarios, and also comparing to other similar initiatives that have been performed in the past. All of this will be used to address these 3 different science cases, one on predictability, one on process understanding, and another on risk and vulnerability assessment. So these are the scientific challenges that are the main drivers for the full work that we're doing here. And of course, not only are we addressing these challenges, but also we are, let's say, consulting with these early adopters, also deriving the requirements from them and trying to address those. And then finally, all of this will be combined in these practical demonstrators where we will deploy these tools on specific locations. Here's a list of the locations we have already. Where we already have numerical models implemented, and we'll then evaluate different scientific challenges in different locations with these tools. And here are them. So these are the set of use cases that we have in EOatSEE. Like I said, those 6 different pilot test areas. Each of them already have numerical modeling chains, so numerical modeling is models implemented for very high resolution to address the short term. Most of these environments are low-lying coastal environments, so which is quite important since we are evaluating risks related to these extreme events. But we also make sure to comprehend a very wide variety of environments, so not only sandy beaches, but also rocky shores, estuaries, open coast barriers, and low-lying islands. And we are even here trying to address some of different hazards, like the isolation that we get in these islands when they are affected by storms. And we'll be detailing this further later today in each of the science cases expositions. And of course, like I mentioned before, each of these locations also has already a set of users or early adopters that can also evaluate our results. So today we are having this scientific requirement workshop. Like I said, it is a community effort. We want to assess the potential of Earth observation to increase the knowledge, the scientific logic regarding extreme sea level events. And what we expect from the audience today is critiques and suggestions. So we want to characterize the gaps that we have in this proposed approach, which will be presented today. But also we want to identify additional requirements, so other challenges, other issues that we're not addressing here, and we want to understand how much they are important and if we should address in the project. And the idea is, of course, to co-create the solutions with this community to provide these informed decision makers for these engage the stakeholders in these use cases, and of course to in the future scale this to the global scale and offer this same sort of tools and products to stakeholders all over the world. Of course, for this, active participation of the audience is key. So as of this morning, we had more than 250 people registered for this workshop from 45 different countries. We have to say this was quite fortunate. We are almost surprised by the interest that we got. So we are very happy. Of course, the workshop is also being recorded. We have people from all over the world that cannot follow live because of the timing, but we will follow this with emails and offer you the possibility to subscribe to our newsletter, be a part of this community, be a part of this discussion. Please, during this workshop, place your questions through the Q question and answer link that you have down in the bottom of your screen, or you can also raise your hand so you can ask directly. We will give you the word. The idea is that we have this agenda. So I'm already doing this first part, the overview, but now we are going to start the scientific sessions. We'll have one for each of the scientific challenge that we have in the project. This is the morning. So each time we will have 15 minutes of presentations by Pedro Almeida, which is the scientific lead from the project. And then we'll have 45 minutes of discussion. So a lot of time for you to interact, to place your questions. Please don't be shy, and let's try to make it as interactive as we can. And the idea is that then we go to the lunch break, and then on the afternoon session, we will review some of these comments from the discussions in the morning, try to get into more details of these specific issues that we think are interesting for the project. I think it's important that I mention here, like I said before, we are going to have a roadmap in the project. So even if we are not able to include some issues that I consider important in the project, we will still include them in the roadmap. So it's important that you raise any questions or any issues that you feel it's important related to extreme events and risks in the coastal areas, and which is of course anything that we cannot address in the project. Like I said, we will be addressing this last session of the day, where we are going to discuss this roadmap for long-term research. And then we'll just do a short closing of the session. And we expect to get a lot of very useful information and requirement to drive the work that we're going to do in EOatSEE. So thanks a lot for participating today. We are very happy to have you here. I'll give the word now for Pedro Almeida, so he can start with the first scientific challenge. And yes, please don't be shy and feel you are very welcome to participate. Pedro, whenever you can share and start.
Good morning. Can you listen, Pedro?
Yes, I'm sorry, I had muted myself, but yeah, I can hear you loud and clear.
Good morning, everyone. Thank you for participating in this event. My name is Pedro Almeida. I'm the leading scientist from Plus Atlantic team. Also trying to do my best as a scientific leader in this EOatSEE project, which has a very diverse team, which have specialists from numerical modeling, from remote sensing, and also from coastal geomorphology, coastal dynamics. So it's quite a complex work, but also very interesting to combine all this expertise into a singular proposal. Which, as Pedro presented, has a very practical, useful applications for society, but also we expect to contribute for science. So I'm going to present these different science cases work that we propose to do, that we will do, and we already started to work on. I will start now with the science case predictability. And in all these presentations, I follow the same structure. So first, I give an overview of the scientific challenge, but I give even more of that. I give the questions, the methods we want to apply, and the way the project will evolve. And then these other two sections, selected use case and objectives, and advanced science tools and approach, are more like a summary of the tasks that we will perform. So, as Pedro commented and already explained, this project is looking at extreme sea level events at two different time scales, the short term and the long term. And the key aspect is to develop these advanced science tools with the best tools we can, and particularly important also to assess the way we can integrate AO datasets into the modeling effort. So if is it on the comparison, calibration of models, or is it in the integration and input in the models? We have to somehow understand what's the best way to extract the most of these different data sets and use in the models. And if we can't do it already, identify the roadmap or the needs that remote sensing, space remote sensing need to evolve to be able to support the modeling efforts. So for the scientific challenge regarding the predictability, in EOatSEE we will be more focused on the high resolution modeling. So the most advanced tools we have to predict this type of events. And for that reason, we will be looking at these tasks, looking to generate short time series. So this typically these events are very short period of time. Calculate indexes and also evaluate and do extreme event analysis with these data sets. As Pedro also mentioned, we have a number of selected use cases where we have already identified early user adopters, which also provide a really important feedback into the project, because their requirements are also they should be considered in terms of what the models and what we expect to provide as a solutions to help their decision making. So in terms of challenge, the overarching challenge of this science case is the evaluate the added value of their products on the predictability of extreme sea level drivers, including nonlinear interactions. And I will talk a bit more about this in the next slides. So extreme sea levels events are short-lived events that normally take hours or a few days, typically known as storms in the coastal areas. And they promote exceptionally high local sea surface height. So the total water level at the coast during these events is exceptionally high. And usually these events result from a combination of a different process. They can be a result of contributions from oceanic, atmospheric, and also fluvial process that take place at different time and spatial scales. So we have long-term process such as land subsidence or relative sea level rise that takes several decades to change over the time, while we have at the same time seasonal sea level anomalies that can promote significant change in the local water levels, as for example in the ocean basins like the south of the China Sea, where you have monsoons affecting and creating sometimes 50 centimeters of persistent sea level above the normal mean sea level. We have also astronomical tides and storm surges, which are also shorter timescales events that promote significant amount of total water level at the coast. Particular important, for example, the storm surge in the east coast of US or in the south of Brazil. And at the coast, we have also the wave-induced run-up, which combines the setup and swash oscillations. And the combination of all these factors promote what we call the total water level. And when this total water level exceeds some morphological features, such as the dune base or the dune crest or a seawall, they can promote important hazards. So as an example of the hazards and also the importance of this different process and the combination of these different processes, we have what we call the compound nature of this extreme sea level events. So typically the hazards, inundation, erosion take place when we have two extreme processes occurring at the same time, or two high water levels induced by some of these processes that I showed before. Here is an example of an extreme flooding that took place in November 2019 in Venice, where we had simultaneously storm surges occurring at the same time as the astronomical tides, and this fact created exceptional extreme water levels that caused significant flooding during this period of time. So it's very important. These interactions is not only the summation of the factors, but sometimes also the nonlinear interactions as the currents interactions with waves in this compound nature of these extreme events in terms of predictability. So some indicators that we have at the global scale, and the projections for 2100 indicate that, for example, the tides and storm surges and waves are the major contribution with 68% to global coastal area flooded, and the mean sea level rise only accounts for 32%. So already indicating that ocean process are dominant in contributing flooding. Also, recent projections for coastal overtopping, considering sea level rise, indicates that overtopping can increase more than 50 times in the 2000 by 2100. And here again, also waves and tides were identified as a key factor, the co-occurrence of these two processes. And more recent studies also are looking into the contribution from precipitation or fluvial discharge into the estimation of extreme sea levels and their impacts, and indicate the recent indications that the storm surge and the precipitation, the co-occurrence will increase globally by more than 25%. This is particularly important in northern latitudes and could become more than 2.5 times as frequent, this type of events. So all these indicators suggest and provide a strong suggestion that we should look into this compound nature and particularly the predictive capacity of predicting this type of events in order to mitigate and adapt to these events in the future. So in the EOatSEE, we will work with high resolution downscaling numerical modeling, because it's an approach that can couple a set of models that translate basically from global scale physical forcing into local coastal flooding projections or other hazards such as erosion, and is a method that is capable to combine a large number of processes and their nonlinear interactions. So this is the most robust way to integrate sea level rise, tides, seasonal effects of sea level anomalies, storm surges, fluvial discharge, waves, and also the impacts. And as you can see here, these processes are combined. They go from different models can be applied from different scales, from regional scales to local scales, and the interaction of all these processes result in the predicted extreme sea levels and coastal hazards. So for the EOatSEE, also the special domain of interest is from regional to local scales. And I will show now some of the questions and the science we will address. So at regional scales, some of the challenges we have identified is the lack of in-situ observations in remote environments such as open ocean, which difficults to the assessment of the modeling predictions, such as the prediction of a storm like the Hurricane Lorenzo in 2019 in the Atlantic. And in particular, this information, the validation, is important to verify if the models are capable to identify the timing, the magnitudes, and the track, the orientation of the track during this storm. So this is an example the impacts that this type of storm can have in remote locations such as islands. And in this case was in Azores Islands, where it promoted dramatic impacts on the coast, impacted severely the port, which in turn isolated the population in the island for several days. And these are some efforts of CMCC to model these regional scales process, so to try to attempt to simulate this storm event. However, there is lack of information to validate or to compare these model simulations in order to provide an assessment of the model skills. So some of the products that we'll explore in EOatSEE to assess this model efforts is the sea level altimetry, the long track products, some of the recent products that are more refined in terms of spatial resolution. Also altimetry, significant wave heights, and SAR wind and wave products. As we know, the missions of altimetry and also the new missions provide different tracks. They have different temporal and spatial resolutions. So the main challenge is to identify if we can, for this specific storm, get the data that we want, that we need to validate the models, or do we need to go and select other storms in order to be able to evaluate the capacity of these data sets to assess the model results. So it's a challenge that we have at the moment, but that we will identify by the end if we can use. So the question we want to ask is that if we can use the EU products, as I mentioned before, in remote locations to assess extreme sea level predictions, are they available always that we need to assess, or not really? Do these data sets fit the proposed? What is missing? So all these questions should be addressed, will be addressed in the project, and provide important insights. At local scales, one particular important process that is poorly studied is the compound flooding of ocean and fluvial components. So we will address this and evaluate how wave interacts with fluvial discharge and affects flooding in the coastal region in the Tagus estuary in Portugal. And for that, we have an extreme sea level event, which did not add an important fluvial component, but we can explore the model, the validation of the model, and try to assess how, if we had a different river discharge, how could that influence the storm impact along the coast. So for that, we will use downscaling numerical modeling that combines tides and fluvial discharge inputs, as you can see in these model grids, together with the high resolution wave modeling and also hazards predictions. So in this case, we also will analyze and evaluate some of these satellite altimetry and SAR or FF-SAR, which is fully focused SAR, which provides higher resolution, higher spatial resolution, long track information. They are quite novel products, and we will try to see if it's possible. We have identified the tracks of these satellites, and potentially they can fit the purpose of this work. So some of the questions we want to answer with this modeling effort combined with the AO datasets is what is the added value of these AO products in predicting compound ocean fluvial extreme sea level events, and how important are the fluvial contributions to coastal flooding during an extreme event. So this will be analyzed with the high resolution modeling. Also at local scales, but considering the hazards, we will do an effort to look at high resolution coastal topography and bathymetry data sets derived from satellite, from very high resolution satellite data. which are typically scarce in low-lying islands. So these data sets typically don't exist. To analyze or to forecast and perform scenarios in these locations typically is difficult because of this scarcity of data sets. And then for that reason, we want to evaluate if with a single satellite passing through this region and data acquisition, can we extract the topography and bathymetry that is able to have the quality to analyze coastal flooding with the same resolution or with the comparable with the state-of-the-art observations such as LiDAR topography. So for this particular challenge, we will use coastal topography and bathymetry derived from very high resolution plate imagery and compare the simulations of very high resolution models using LiDAR or using this data set. So summarizing the use cases and objectives for the Açores and north of Madagascar, we will assess the nonlinear interactions between meta-ocean process, not only waves and surge, but also currents and waves interactions during extreme events. Demonstrate the added value of EO products to assess the model skills in remote locations where no in situ observations exist. And for Lisbon and North Adriatic Sea, we have similar modeling setup and conditions. We will assess the nonlinear interactions between meta-ocean and fluvial process, so the river discharge during extreme events. And finally, for Marshall Islands, for the Majuro Atoll, we will assess the added value of very high resolution EO products, particularly topography and bathymetry, to predict flooding hazards in the isolated islands. So in this table, I present the use cases and also some information, not the all information about advanced science tools. So considering that we call advanced science tools the combination of models and EO products that are used within the modeling chain or in the validation, calibration, setup, or input. But also in addition to this, we have other data sets that are being used as a comparison. For example, at all of these sites, we have data sets that have been previously used to set up these models. So they are already calibrated and applied in these different use cases. And that data set will be used in some cases to compare the model results or to use in the simulations. So the different models we have are different solutions for downscaling modeling, as the SURF developed by CMCC, MOHID, and SWAN in Lisbon, SANIPS, the system implemented in the Mediterranean, which contains SciFAM and wave models, and also a Deltage package of models such as Del3D, SWAN, XPitch, and Sphinx for flooding assessment in this Majuro Atoll. So different modeling tools, which also is interesting because we are comparing similar, in some cases, similar data sets, or integrating similar data sets, or even investigating similar process, but using different approaches, different models. It could be an interesting way to intercompare the modeling results. And also integrating in some of these cases some physical properties of the coastal zone, such as the bathymetry or the topography and bathymetry in these two use cases. So the approach of this science case, the general approach, is to select an extreme event, hopefully that suits the EO data sets. We want to compare these two data sets, the modeling results with the EO data sets, particularly the meta-ocean observations. And by comparing it, we can evaluate how these advanced science tools are predicting these events. How can we improve it? Can we somehow, in a simple way, assimilate this information or in the inputs? Can we use it? Or even this information provides new knowledge that can be incorporated in the modeling calibration and improve then the modeling results. So now it's open to questions, to feedback. You are very welcome to contribute with any idea or suggestion that you want. I will stop my micro now.
Yes, thank you, Pedro, for this exposition of this first science case. Maybe Pedro, you could leave the presentation on that slide with the map, where you have a summary of the science cases and the questions that are to be addressed in each of the use cases. I think that helps the discussion. So we could maybe start by addressing a little bit of the river contribution, which was the topic raised by Professor Hutchins. So I think he has a question regarding, of course, the consideration of these river flows, but of course he made the question right before you showed the use case in Lisbon, where you want to address this contribution also. But maybe you could provide a little bit more detail about this, Pedro, and then Professor Hutchins can also maybe contribute if he wants and answer you and confront you with some questions maybe.
Okay, so basically, yeah.
He's raising the issue of are we considering these river flows, which can be quite large in storms and raise these levels, sea levels in especially in the estuaries. So in this case, from what I know, we already have a downscale model implemented, and we are using discharge data for the river.
Yeah. So thank you for the question and to putting this to raising this issue. I think it's the recent literature is addressing this and is becoming more address this issue or this process, I would call it this way. And basically the important aspect of considering the fluvial components is that it cannot be addressed as a single addition of process. It is not a simple. Sorry.
The deliverables called scientific roadmap. Of course, it's delivered at the end.
I think it's
but it would be nice to open the document as a notebook and start, you know, pumping ideas that come out of some brainstorming or, you know, obstacles you run into, and make it like an open document for you to gather things as you go along until the end of the contract, and then shape it and deliver it, and eventually you can report through the monthly report things that you thought would be good candidates to end up in the scientific roadmap.
Oh, hi, Jerome. I'm not sure you're speaking to us in the meeting about the scientific road.
Just one comment. I was checking.
No, I think it's on another chat. So.
Can you hear me?
Yes. Can you turn his micro off?
Yeah, I'm trying to. Yeah.
It could be a suggestion for us as well.
I was listening also, but because indeed we're doing that as we speak. I'm taking notes and I'm preparing a board so we can discuss not only the roadmap but also the actual work that we want to perform within the project on the afternoon sessions. So we are following this discussion more specific now with a wider discussion on the roadmap. So Pedro, you were speaking about the how to add this river contribution.
Okay, so I was just going to add let's say a justification of integrating this process into the modeling chain, and particularly in this study sites and in another study site that also we have in the North Adriatic Sea. I'm not sure if Giovanni is, but we also could then mention his case. But basically, this process, they cannot be considered as just an added level into the modeling, let's say, into the model predictions. The fluvial discharge has an important interaction with incoming waves. So there are currents and wave interactions. There is also the tide phase. So all these processes have a really important nonlinear interaction that can affect importantly the flooding forecasts when these events occur. In this particular site, we don't have typically we don't have at least a recent event, a large event of a river discharge that affected and could be observed the impact of that in the coasts together with the ocean extreme event. But also because we have probably something that has to do with the human intervention in terms of the discharge. So there are several dams along the Tagus River that arrives to this location, to the estuary. And this can be one reason why we don't have probably more impacts of fluvial discharge in extreme events. Because there is a control, it's not natural, it's a human intervention on the control of this flow discharge. So naturally, probably this would be more prominent, the effects of the river discharge in this study site. But anyway, we will explore using probabilistic scenarios of river discharge. We're using observations. We have a long time series of observations of this forcing, and we will combine that with a validated model for oceanic events like this storm Hercules, and try to synthetically analyze the potential impact of this discharge.
Maybe just to add, Pedro, that of course, in terms of observation, you mentioned several tools in your slide, and for instance, the along track sea level altimetry that we get in the data sets. With as long as these tracks, these satellite tracks are perpendicular to the coast, we can get very close to the coast. So the idea is that we can validate, or at least compare to the results of the model, the total altimetry in different points of the estuary. So if we can do that, and it's still for sure it's a goal, but I'm not sure we are going to get it, because of course we depend on having data exactly at the same time of the events that we are interested. And with altimeter data, we have a bit of a limitation in terms of temporal resolution. But so if we're fortunate enough that we get data in the same time of the events that we're studying, we might be able to evaluate these differences in altimetry along the estuary, and then it will also help us understand how this river discharge is being considered by the model. So that's where observations also become quite valuable. So yes, more interactions. We want to have your questions, not only your questions, but also suggestions. So regarding data sets, regarding similar initiatives or projects, we are very interested in understanding if some of you are doing similar work that we could collaborate. So right now, I don't see many interactions. So maybe we could get in a little bit more detail of again what sort of data we want to use. So like maybe in the next table, Pedro.
I don't know if something also we can provide a little bit more insight. I don't know if Claire is here from CLS. A little bit more insight, for example, in some of these products that I just mentioned. So these are different types of products that measure the surface height, and some of these are already also retrieving wave information. The fully focused SAR, it's a sensor that collects, for example, at very high resolution, spatial resolution with 300 meters spacing, information of the surface height at very close to the coast. So this is probably one of the sensors that gets more information near the shore, which typically does not happen with the satellite, the typical satellite altimetry, which normally has spatial resolutions of 7 kilometers. Some of the recent products that are available in the project go to 1 kilometer spatial resolution. And so with 7 kilometers, we don't get so close to the coast. And typically this type of information has problems getting near the coast, are somehow affected by the land. And so having some of these products that potentially can give us information near the shore, it's something really new and really interesting to look at, because then we could start to somehow integrate these data sets into the validation process, at least, because the temporal resolution of these observations is still not compatible with the temporal resolution of the process of the extreme event. But at least we could start to assess or get information probably in locations where normally we don't have information. So that's something we really want to take the most of it in this project, since we have already set up the models set up, the model infrastructure is there. Now it's just a question of combining the data sets and assess the timings of the coincidence of the data sets and explore as much as we can. So I don't know if Claire wants to say something, or even Giovanni, about the CMCC case in North Adriatic. Otherwise, I don't know if there is other questions.
Hi, Pedro, I'm here. But I think you already mentioned a lot regarding altimetry capabilities and what we plan to test during the project, particularly with this fully focused opportunity for the Sentinel-6 and Sentinel-3 missions. So for sure, the idea is to make some samples over the use cases. So we'll try to do it for all if needed. And so this is the ongoing discussion with between the modeling team and the Earth observation team.
Here, even from CMCC, also to complement a bit about the part related to the compounding effect in our modeling approach for the Northern Adriatic. So river-sea continuum, river-ocean continuum is one of the key elements in modeling with the high resolution. And in addition to what already Pedro mentioned, to look at the events and to see at the different components for a specific event, we can perform also some let's say what if scenarios where we could see what's happening if the highest component, if each component are occurring at the same time, providing the highest contribution, for instance, for what concerns the surge induced by wind, the waves, the ice, the river flow, and also the timing of highest tides in relation also at the different components that we have in the system. So all of these components are present in the system, and we also can try to do an analysis of attribution of these components and compounding with the same timing to see at the maximum effect of the surge.
Thank you, Claire and Ivan.
Yeah, indeed, this last comment from Ivan, it's pretty aligned with a question we are getting from Professor Jimenez. So it's regarding the timing between the drivers, this surge, storm surge and the river flow. So of course we know this exactly like Ivan mentioned now, the synchronization of these effects, it's quite important with tidal effects, of course. So how can we address this with Earth observation, since it usually has a low time resolution? So I guess this is, of course, we cannot prescind of the numerical models here, Pedro. So maybe you can address a little bit this.
The temporal resolution. I think this is the main, let's say, the main question we have now, and the main challenge. And then that's why we are just, let's say, starting or trying to do this as much as we can to assess where we can use these data sets and how they capture or not the events that we really want to look at. So this is the fundamental question. Are these products ready to be used, considering not only the observations they do? So we are talking about very advanced tools. We are not talking about something that is not at the state of the art. So they are really interesting just by comparing it with some observations or even modeling results. That's already something that it's novel and interesting to do. But if you want to push it to a direction where they can actually be used in an operational mode, and to even serve as an input for the models, I would say that would be the perfect ideal condition to use this as a input in the models. But even just for validation, there is a big challenge in capturing the information at the right time in the right place. So I believe that with these efforts we will do in different use cases, different storm events, different scenarios, we will be able to answer if these products fit or not the proposed, and if there are two aspects we can analyze. We can analyze in terms of observations itself. Are the observation really the type we need and useful for the analyzing this type of process? And also, are they operating in the let's say in the configuration that we need to look at this process as well? I believe we can look into answer this. For now, we don't have for sure the answer, but we are definitely working together. For example, Claire that just spoke is from a CLS specialist in developing all these products. And we have also even modeling a specialist. So we are combining these two teams, let's say these two expertises, to communicate and to try to address this issue. So that's what I can say for the moment. Hopefully next year we have much more in-depth responses.
Yes, indeed. In the end, we are really depending on the model. Of course, we cannot do the estimation of this, let's say, high resolution, short-term approach with just Earth observation. So we are depending on the model, but we want to understand how much can we improve the model reliability and the confidence that we have on these tools that are pretty much the standard approach that we have for coastal engineering for several different applications. So we want to double check how come we can improve and validate this approach using these observations in the short term. So we are getting quite a number of questions right now. So Pedro, another one from Mylan is addressing the wave run-up, as we already had also a lot of discussions regarding this in the project. It's quite an interesting topic. It's quite a challenge to get this right in the modeling approach. So that's where, again, we're depending on this combination of models with Earth observation data, and we are very optimistic that we can get this wave data much closer to the shore, so that we can test this and compare this to in situ measurements, but also to the model, of course. So I don't know if you want to add something here.
For this, for this particular predictability science case, since we focus on the existing high resolution downscaling modeling setup already existing in these different use cases, we somehow organize, let's say, the activities to get the most of the existing models set up. So in this, as you've seen in the presentations, I didn't focus too much on the nearshore process. It was more on the somehow regional at this fluvial ocean interactions. There is a little bit more local, and also at Majuro Island atoll, we will look at more in detail into the nearshore process. And in this case, we are using EOatSEE model to look at the wave transformation and wave run-up. Delta's team is responsible for that. And then there is also another model called Sphinx, which let's say propagate the inundation in inland environment. So it is the inland flooding model part of this model chain. In other let's say science cases that I will talk about, we use where we look at long-term time scales. We look at run-up explicitly using the empirical equations, normally the Stockdown, but so it is basically that. I mean, in terms of numerical modeling, we use the existing models that we have that can be able to predict run-up and then also the flooding extension. And in the empirical or simplified analytical approach, we use empirical equations to predict. And these empirical equations are typically fed by offshore wave information. And possibly, and this is also related with this, just this discussion about this, some of these products like the FFSAR. Maybe this could be something to explore in some cases where we have these tracks aligned perpendicular to the shore, where we can assess the wave information. Maybe we can also explore this as an attempt to assess the wave information near the shore, near the, let's say, the region where the run-up takes place. Maybe this could be something to assess and possibly improve the forecast of run-up if you have informations along the dissipation of wave and in the near shore zone in shallow waters. If you have some information from the wave transformation, possibly you will improve also the wave run-up estimation. So it's not the main objective to look at specifically of that, but it's something that probably will come with the analysis. I don't know if I answer directly to the question, but I kind of give an overview of how we are dealing with these different model solutions and particularly looking at run-up.
Yeah, Basically, when talking about short term, we come back to this limitation about the temporal resolution, and so this is related also to the previous question. When talking, even if we get this wave information closer to the shore, which is going to be, I think, one of the key results that we want to get in the project, because it's quite interesting to get this data and compare to the let's say boundary conditions that you're putting in your profile evolution model. So if you get the wave data on the base of the active profile, that's where we want it, and then we can use this data as an input for models. Even then, it's not going to be enough for the short term, because of course we have the limitations from observations from satellite regarding temporal resolution. So it's a good opportunity to compare to the approaches that we have, but we are not still in a position that we can use this to address the short term. As Pedro mentioned, this will be much more interesting and useful when looking at the long term, because then, of course, then we can actually take advantage of the satellite, let's say, characteristics of offering a long time series in a global coverage. So when addressing a lower resolution long-term approach, it's going to be more exciting, more interesting. Here for the short term, it is another possible comparison that we will be doing, but it's quite limited in terms of input for the model.
Pedro, just maybe to suggesting, maybe in addition also to the questions, the suggestions are also very welcome. So if the people is assisting, the experts that are contributing and making questions, also they have some suggestions of some of the things we are addressing, and they believe they have better ways or different views. It's really very welcome to have that feedback. Please feel free to provide any criticism or any other suggestion in terms of what is being discussed here.
Yes, excellent. Indeed, we're getting suggestions already, and I'm taking notes. And don't be worried that we cannot maybe cover all of this in this morning session. Like I said, we will have more time in the afternoon, and we are going to be coming back to some of these topics. So I want to raise another one that was raised by Antônio Jorge da Silva, a colleague of mine in Atemos. So it's regarding in situ data, because of course he's suggesting that we wouldn't be, are we considering to complement this observation from satellites with actual in situ measurements of a wave, and in some cases also with surface drifters, also observations of river discharge even. So for sure, this is very interesting. One of the key advantages of this project is that we have at the start already this numerical modeling chains implemented in each of the use cases. So of course, with the numerical models also comes a lot of data, a lot of inputs data, a lot of validation data that these locations already have. But of course, any additional measurements, and especially during extreme events, would be extremely helpful. So for sure, that's another thing that we're very much interested. So you guys are seeing, all the audience here is seeing the locations, the use cases. And if you have other data, other studies in these locations, we are very interested in using them, in trying to explore them. Of course, when talking about comparing this with satellite data, it's much more useful if they are within the Sentinel area. So in the latest 7 years, it's going to be more interesting. But even prior to this, we also have some good data sets that we can compare. So very interesting in this, and we should foster this collaboration and maybe foster some of these experiments, especially with the surface drifters, could be quite interesting. Also, we got also an offer, especially for this Lisbon use case from LENEC. They have several studies and several modeling efforts that they have performed that. So for sure, we're going to review that and try to collaborate. So thanks, Francisco, for that. So also getting now.
So just commenting on that.
Yeah.
Just commenting on that comment also from Antonio Silva. I think we are still not in a level where we can say we only use one data set or one tool to look at this process. So I think the combination of all these different sensors regarding in situ, remote satellite remote, on the land remote as well. This is something we are not addressing so much in this project, but it's widely used for many of these different processes that we are discussing. So again, someone. Hello. So I think the key at the moment is definitely the combination, because as we know, the tracks, for example, from altimetry, still not have the temporal resolution or even the spatial resolution probably that we need. Probably the microsatellites and nanosatellites that are new constellations that are arising may change this, but at the moment we are using the non-commercial or partially the non-commercial solutions that are has some awesome these limitations. They have other objectives, so not only to measure this type of process, and so they are not fitting completely the proposal. The in situ observations are fundamental also because they are more let's say solid in terms of measurements. They have been consolidated for much longer time periods, so they somehow are more trustable in terms of what information they give. They are also useful even to compare with the satellite information. So definitely in situ is an exceptional addition to any of these use cases, to any modeling effort. And I think the way to go is the combination. Actually, what we call advanced science tools in this project is that fact, is the combination of in situ models and satellite, and even other solutions, for example, intelligence, artificial intelligence, or other solutions that can integrate these different data sources.
Okay, excellent, Pedro. I think we are now in the end of this first session. So I just want to comment on there was a last question by Ellen regarding the float maps. So indeed, maybe it was not noticed, but Pedro mentioned quite quickly, because we have a lot of things in the project. But indeed, we are using float maps to validate this float extension. Of course, this is, as you mentioned in your question, Mylene, this is very dependent on the timing of these images. So if we get these images, especially SAR, in the time of the storms, we of course will try to validate this float extension. So this is in the scope. It's especially important in the Majuro Atoll use case. We want to look at that. So it's for sure in the scope. We're going to try to use EO to validate this float extension that we get from the models, and that's kind of the approach that we have here always, and trying to decouple the river from the ocean contributions. That's another part of the questions. Using Earth observation, it's something that we cannot do using only Earth observation, but as we have been explaining, the target here is for a combination. So we want to improve these numerical models by using the Earth observation to validate, to have more input data. And if we're able to do that, then of course we can use the model to try to decouple this contribution from ocean and river. It's not something that we can do solely with Earth observation, but we'll try to improve the models and use them to do that. So I would like to propose a very short coffee break, like 3 minutes. It's just so we can take some breath, take a glass of water, and we come back at 10:20 and continue the session, or 9:20 for the ones that are in the UK and Portugal. So see you all in 3 minutes, and we start again for the next section. So welcome again. This was a very short break. It's just early in the morning still, but we're going to continue. So the next session will address risk and vulnerability assessment. We want to call this challenge the tipping points of coastal systems, which is a very open name since we have a lot of things here. It's going to be quite interesting. So I'll give the floor now to Pedro and for you to it's going to follow the same routine. So Pedro will give this presentation 15-20 minutes, and then we have another 40 minutes to discuss it, and any remaining issues we can also discuss in the afternoon sessions. So welcome, Pedro.
So now the second science case, which somehow could have been also the last, because all this predictability process understanding is contributing to the creation of tools that are somehow evaluated and developed in order to fulfill solutions to be able to be applied and serve the decision, for example, decision makers. So the same structure of presentation, first talking about general challenges and also some specific aspects of how the project will implement this science case, and then summarizing this information in the two last slides. So in this case, for this science case, we are looking at the challenges, the tipping points of coastal systems, and in order to arrive to this definition of a tipping point, we will also develop what we call the storm-induced hazards. And using these indexes, we will be then able to define what are these tipping points. So in this case, we will look at both temporal scales, so short-term and long-term. The main difference is that there are several differences, but the main are the tools we are using. In this case, for the long term, we are using analytical solutions, more simplified somehow, that can be able to apply more exhaustively. High resolution numerical models required long efforts and are not, in some cases, not suitable for a really long-term forecast. And so we adopted for these reduced complexity models. Also, in this case, we are not looking at specific short-term events. We are looking at generating a time series of extreme coastal water levels for more than 20 years to then explore in extreme analysis, but also to be able to look at trends and future scenarios. So the first aspect that we consider is that when we are looking at extreme sea level, and if we are trying to identify somehow to translate the model assessment into an index, into a results, typically we do this only analyzing flooding or erosion separately. So typically that's the way normally this is performed. However, as we know, when we have water levels at the coast at the point where the water levels collide against the dune face, we have mobility of sediments, we have erosion at the base of the dune, instabilities and erosion as a response of the dune face, as an avalanche. And when these water levels increase, such as in the case of overtopping or overwash, you can observe also significant morphological evolutions at the barrier crest or dune crest by mobilizing the sediment of the crest to inland regions. And when you have more extreme sea levels, in situations where the sea level is persistently above some morphological feature at the coast, then you have what is called the inundation regime, which is the case when you have a breach in a barrier and the communication of water with inland lagoons or other environments is permanent. So what we can understand from this is that looking at extreme sea levels and not quantifying at the same time the response of the coast is somehow incomplete analysis. So we should consider these two elements at the same time. And this is especially important in low-lying sandy environments where the mobility of these natural environments is very large. In other geomorphological environments, such as rocky shorelines, we probably can neglect the erosion, but in this type of environments, this is especially important. In addition to looking at the shoreline or the boundary between the sea and the coast, where typically this assessment is performed, we also need to quantify the potential flooding impact, because in some of these events, when we have really large storm surges, for example, in the east coast of US, or even in this tropical cyclone in Mozambique in 2019, only the indicator at the coast is not sufficient to quantify the potential impact of this extreme sea level event. And then, for that reason, it's important to also to understand what is the flooding extension and depth beyond the shoreline boundary. So these two types of information, so the erosion, flooding hazards, and also the extension and depth, can be then also translated into something meaningful, something that can be used by decision makers as somehow indicators to understand how the system, how specific aspects of the system are still working well or still behaving normally, or are there some dramatic change that need to have some actions. So that's why we came up with this definition of a tipping point, or also we can call it somehow a threshold, where potential hazards can dramatically change the coastal morphology, for example, but also this type of thresholds can be defined when we identify a certain flooding extension that can affect crucially the infrastructure, for example, the urban area. And for that reason, information about or defining these thresholds first should be a work that should be done together with decision makers. And secondly, it should basically should be able to contribute to somehow to long-term adaptation or mitigation measures. So the approach we have at EOatSEE regarding short-term and long-term is to use different modeling tools, as I explained before, the high-resolution dynamic downscaling modeling for the short-term, and particularly we will be looking at the storm index index called the potential storm surge flooding maps, which indicate the extension and depth of flooding in a coastal area. And for the long term, we will using two approaches, also to compare, but also to combine the linear summation approach and the reduced complexity modeling that I will explain just after, and the storm hazard index. So, for example, the potential storm surge flooding maps, it's an index that provides the extension and depth of inland flooding. It's quite a simple index, and it can be computed when you have tools to do this, or using the bathtub approach, connectivity modeling, or using numerical models. You can develop this type of maps where you can assess the flooding extension and the depth along the specific area of interest. We also will explore in this project the satellite-derived flooding maps that are built using a combination of optical and SAR observations, mainly for the validation process. So if we have a case where we have a storm and we can have the simulations assess the extension and depth of the flooding, and we have a flooding map derived from satellite, we can compare both and assess if the modeling results are comparable or not, in order to provide a sort of also validation into the models. So the EO solutions to be evaluated in this case, so as Maduro Island, is the coastal topography, as I mentioned before, very high resolution topography and bathymetry. And then also we will check if there are available flooding maps that we can use to compare with the events that promoted flooding. For the long term, we will use recently developed storm hazard matrix, which is basically an approach that combines both flooding hazards and erosion hazards, and it's very intuitive and simplified approach that we can compute this. You need for the flooding hazard is a typical Salinger 2000 impact scale conceptual model where you compare the local total water level with some features of the dune or other morphological features at the coast. And by comparing these two levels, and you can have a quantification of different potential impacts that are called regimes. For the erosion is very similar. You have also indicators of the shoreline erosion, and you maintain the same indicators of the coastal morphology. And by comparing both, you can also have an indication, a quantification of the potential impact and classify this impact. So the translation of this into a matrix of colors, as you can see, is it provides a very direct indicator to understand what are the flooding and erosion potential at the same time when you are analyzing the extreme sea level events. So the approach to be used in the EOatSEE in terms of generating long time series of extreme sea level at the coast is there are two. One using the linear summation downscaling approach that basically combines all these processes together. Here, as I was mentioning before, the run-up is computed using empirical equations that basically use the morphology. The only element that used from the morphology is the beach slope, and it does not consider, for example, these morphological features such as subtidal bars. And the important aspect of this approach, which is widely used, for example, for global scale assessments, is that the coastal morphology is static. It does not change over the time. And as we mentioned before, for using the storm matrix index, we need to also have the erosion, the quantification of erosion. And for that, we are proposing to use the forecasting coastal evolution model, FORCE, recently developed by Davison, which is a reduced complexity but fundamentally physics-based model that can be used to estimate the morphological evolution of the coast from short-term to long-term timescales. It uses equilibrium, disequilibrium concepts that look at the wave dissipation at the nearshore zone and how that equilibrium, disequilibrium then provides a response of the coast over the time. So it is able to use this model at a profile and to look at changes such as erosion of the dune, but also deposition and development of the subtidal region. So in this model, all these morphological features are also considered. And so with this model, we also consider the dynamic and constant adaptation of the coastal morphology to the extreme sea level events. And then we can be able to compute the storm matrix index a long time. So the use cases and objectives we have for this science case, we have several sites where we want to evaluate the uncertainties of potential storm surge flooding map. So we are basically sites where we have the downscaling numerical, high resolution numerical modeling, and we have somehow a solution to assess also the flooding extension and depth. And for the long term, we will be mostly focused on these use cases. Possibly other use cases will be used as well. It's for this type of modeling, it's important to fulfill the requirements of the model. It needs to be a sandy beach. It's not a model developed for other types of coastal environments. So, and in these cases, we are selecting for now these two use cases. And here we want to evaluate the uncertainties of the storm hazard matrix using the integration of these models with AO products, and determine the threshold or the tipping points that can dramatically or permanently modify the function of coastal systems. So considering that we are using for this the storm hazard matrix, and this is something we should be able to co-design or somehow communicate with early user adopters to define. So the use case and advanced science tools for short term are basically the same I've presented before. The same tools, and the approach here is to select an extreme event, evaluate the uncertainties of the potential storm surge flooding maps, compute it with integrating the AO, for example, bathymetries, topographies, or just comparing it with the existing data set. So we will perform simulations using the integration of the new AO datasets, and also simulate without these products and just using the traditional setup of the model using in situ datasets, and compare and assess the uncertainties. For the long term, we will be using another amount of tools. So as I mentioned before, the linear summation downscaling and also the force model will be implemented in all the use cases. We will also use existing models at the different cases. So for example, in Dutch coast, there are analytical solutions that were implemented during Endure project that we will be able to use to compare. We also have existing data sets and time series from Almar et al. 2020, which made a global assessment of overtopping using similar approach to the linear summation downscaling approach. So we'll be able to compare what the indexes computed with these different solutions give us, and assess which are the best solution to use. In terms of physical properties of the coastal zone, we will use, in addition, also shorelines derived from satellite using CASI tool. This is mostly for validation, possibly calibration of the modeling. Topographic profiles to set up the models, in principle from in situ observations, and then also the other already pre-identified data sets. In terms of meta-ocean forcing, we will use, in this table is not all the information that we will use, it's only partially, because it was probably too much information, but we will use a long track sea level altimetry, possibly these data sets, I'm not quite sure yet, but for sure the sea level altimetry to get the trends and also to get the sea level anomalies. The wave data from IntCast, so this is something we would prefer to use satellite, but still are dependent on the IntCast dataset. And surge datasets are also from GSTM model or even other solution provided by KINES and CLS. The approach for this long-term time series is then to compute for more than 20 years, apply and calculate the storm hazard matrix using these tools, and compare the model observations using AO, the new AO products, and the other solutions that I have explained in this column. And basically, at the end, we want to evaluate how these new advanced science tools improve or not our predictability capacity, how much important is also to consider this both combination of morphological changes and flooding forecast at the same time, and how they can somehow modify the results in the long-term assessment. So this is the presentation I have for the science case risk and vulnerability assessment. Now you are free to put questions and suggestions and critics.
Yes, so again, very open to suggestion, critiques, and collaboration from the audience for similar initiatives, similar approaches that you might be applying in your work. So this is quite a complex use case here that we have both in short term and long term. Of course, in long term is now we are proposing to use Earth observation actually as an input to this simplified models. So it's not only for validation or comparison anymore. We are actually using it as an input, complemented by reanalysis, where we don't have enough temporal resolution. But of course, we have a wide range of different EO data sets that we are using for waves. We can use SAR, we can use altimetry, we're also using SAR propagation. We are also using proposing to use CFOSAT data, which is directional spectra from waves. So it's a wide variety of data sets, always with a bit of limitation in terms of temporal resolution, but that's why we need to combine them and complement them with reanalysis. But of course, this is going to be compared to the usual approach, which is based only on reanalysis. So yes, again, very open to contributions and comments. Anything that was not so clear?
Yeah, I think just to add a bit to the top to this discussion, I think also in terms of approach is interesting to use indexes that combine the two hazards that typically take place at the same time in most of the sandy environments. So if we are looking at forecasting inundation or flooding at a coastal region, and if you have an extreme event that, for example, caused overwash, and the dune crest was lowered, the next event probably will be the threshold or the linear to the next event to overwash probably will be reduced. So there is a clear necessity to let's say to consider these two processes at the same time. If the tools are ready to do this, we will see, we will assess, we will try as much we can understand what is missing. If it is not possible to do it as we want it, but definitely I think this is one thing we should consider when we are looking at flooding vulnerability or exposure or process that deal with extreme sea level events at the coast. Definitely the erosion component, or at least the morphological response, should be integrated.
Yeah, so maybe Pedro, you could just go back, since you have the presentation in the screen, go back to slide 10 to illustrate what you're speaking about, this combining the next one, yeah, the next one, where you have the scale, yeah. This is the sort of, let's say, scoring that we will attribute to build this time series of this scoring. So this index is quite interesting. It's one of the central results that we expect to have in the project. And one of the key advantages of this index is its scalability. So we will aim to use input data sets here that are available globally. So while in the project, we are only gonna produce this in the use case areas, it's gonna be ready. It's gonna be a tool that's ready to be scalable, and it's gonna be possible to do these estimates across the world. So and in different time ranges, depending, of course, with the data that you're using. But we will aim to have a very scalable index here. So it's going to be one of the key results that we expect from the project, especially this one, which considers both processes combined. We will compare with a more, let's say, traditional approach, but this is the key innovation that we expect here in terms of long-term approach. So everybody seems quite happy with the solution. I would expect some reactions here, since it's quite a new topic. Okay, so we have our first question now from Catarina Duarte, how citizen science could be taken into consideration in the project. So I would say from my perspective, the first it's actually the first contribution from citizen science is within the communication and the interaction that we have with these early adopters. As Pedro has mentioned in his presentation, when talking about local tipping points for these hazards, for both erosion and flooding, the local experience is for sure one of the most valuable information that we can get. So in some cases, while in some cases these tipping points can be related to natural setting, like I don't know, a frontal dune or something, they can also be related to infrastructure, to critical infrastructure that if lost, then it cannot be built again, or it's not well feasible to build it again. It's not interesting to build it again. So in a lot of cases, it's important to talk and discuss with these local stakeholders and to understand better what are these actual critical infrastructure, what are the tipping points that are they are on their opinion they consider tipping points for their local setting. That's one contribution that we expect from citizen science. Another one, it's regarding the extreme events themselves, because whenever you have extreme events, you usually get a lot of information posted in social media, and not only in the news, but also in social media. So we also want to explore that to understand and try to consider the impact of these events, but mostly to identify the locations and the time spans of these events where we should take a closer look, and of course verify if they are being well represented in our time series, both for the short-term and the long-term approach. So I think those are two main ways that we can accommodate citizen science in this project.
I also like to maybe to comment. So I see the possibility of citizen science also in something more, let's say, instrumentally, because as we know, there are at least one initiative that capture information from the shoreline at the coast snaps, if I'm not mistaken. And this is almost like in situ observations, any kind of citizen science that provides in situ observations, for example, to assess levels. So when we are trying to model these total water levels at the coast, we have several uncertainties associated. We have uncertainties due to the topography. We have uncertainties because we are using typically empirical, for example, for this case, empirical approaches that were built with specific data sets. Sometimes they don't fit exactly these site-specific aspects of the coast, the morphology, the type of the sediments, or the type of the geomorphology and geology. And so there are several uncertainties regarding all this process that start almost from the wave base up to the coast. And sometimes this type of information that is collected by citizen science, even just photo or something that can be then translated into an information of a position, for example, of the boundary of this sea level. I think that could be something to look at. It's not something we are looking at in this, particularly in this project. It's not in the scope, but I could see a useful application of this type of citizen science information that could really contribute to the tools. Actually, not what Pedro said. I totally agree. This component of communication with the stakeholders and citizens, but also from the observations point of view, I think citizen science has a potential to add also to this. So again, in situ observations of any kind of way to get information that can validate this boundary, it's extremely useful. So maybe suggestion to someone who wants to work on this together with us.
Yes, indeed. This is quite important that we mention, as much as for the surface drifters that we discussed in the previous point. So the in situ data. We also are very interested in this kind of data from citizen. It's citizen science. It's not something like Pedro said. It's not something that is currently being covered by the project. So we have not included tasks for doing that. But we are keen to use this information. So whatever. If you are planning a project right now and you want to explore some use cases which were very rich in terms of data, we are very pleased if you want to collaborate with us and deploy some citizen science tools in the same locations where we are going to be exploring this data. It would be, of course, enrich a lot the project. So we have now another question from Joaquin Paes Barbosa. So the project will only include natural dunes. Do you consider to introduce sandy beaches with coastal works to analyze the possible contribution to reduce the impacts of extreme events? So I think maybe one of probably the best example that we have in the project about this is the Dutch coast, which is of course an object of well, all the interventions we can think of. So Pedro, if you want to comment on that, but also Marika and Tony, if you want to intervene and maybe mention a bit how we considering this works, this anthropic contribution on the beach, this engineering work in these models.
I can just give a quick comment. In terms of modeling, this model, I believe I never tried, but I believe it has a physics enough to somehow test the changes in the profile. So basically, if you put some sediments on the front or on the top of the dune, it will be quantified in the model. So I believe that's possible to explore this type of tools in terms of, for example, how efficient is the certain type of dune alimentation and nourishment. So it's not, again, not specifically in the scope, but possibly also very interesting, because if we're talking about tipping points, if you're talking about risk and vulnerability, and all this leads to mitigation, adaptation measures, it's definitely something we should be looking at least. We should be at least testing it and evaluating if it's feasible. But I think it's possible, yes.
Yes, I think this is Marieke from Deltares speaking. I think this is what we've been mailing about before, that this is something particular of the force model, where you could put in these beach nourishments, for example, which we have at the Dutch coast, and compare that with the Dean profiles, where you come to an equilibrium, but with beach nourishments we help or we change this equilibrium. So I think it will be a very interesting comparison from that sense as well.
Excellent. I'm trying to take notes here at the same time. So thanks, Pedro and Marieke. Indeed, I think the Dutch coast will be the best possible playing field for this topic. We have another question now from João Campos. Did you take into account the added bonus of marine and coastal plants, algae, etc., in reducing the washing of beaches and erosion? And how much any countermeasure aids in growing this natural and living structure? So a bit about nature-based solutions regarding the vegetation coverage.
In terms of vegetation into the models, no, it's not in the physics of this model in particular. So yeah, what was the question just before? I think it's possible to just change volumes and morphology, so simulating a nourishment. But in terms of vegetation, I'm not. I don't think it's possible for the moment, at least with the physics there is in the model in the moment. So yeah, my answer is, for the moment is I don't think it's possible.
I would just complement this, Marieke. Within the endure approach, you also cannot implement anything about vegetation coverage. Is this the case?
Indeed, we did not implement it particularly. In fact, of course, the coastal dunes and the way the Dutch work with the dunes, so they stimulate them to grow by, in the past we did it by marram grass, for example. That's of course a key example of a nature-based solution, which we've been doing a long time. This is why these Dutch dunes are so high, by the way. About coupling of models and nature-based solutions. Some work has been done by Deltares, of course, but that is, I think most of the work was not particularly for these dune environments. So we're not thinking of using that in this project. But if you want to know more, I can of course give the context of some colleagues that have been working on this. We did a lot for these salt marshes in other projects.
If I may just perhaps also add to that, indeed, from the cases, and certainly the cases that have been done by Deltares, to sort of, say that, yeah, that the actual influence of nature-based solutions was not specifically part of this project that we're doing. As Marieke said, we're doing work on that elsewhere, and we'd be happy to share that information. From the EO-based approaches that we're looking at here, which is the endure approach on the Dutch coast, but also we're looking at the effects of flooding and overtopping in the Marshall Islands. Then it's most important to us to have the correct foreshore bathymetry, and that is one of the aspects that we're looking at here. So, for example, in Majuro, in Marshall Islands, the effects of the under or the very shallow coral reefs, which in other aspects of nature-based solutions are also taken into account as effects of reducing flooding. So we're not specifically looking at the nature-based solution, but looking specifically at the effects of foreshore, and the shape of the foreshore and the depth of the foreshore is a very important aspect that we're trying to get out of this approaches to then incorporate into our local modeling, whether it's in Dura or whether it is then used in XBeach or Sphinx or whatever. That's the approaches we're looking at.
So indeed, that's I think the complementary answer here. We are not addressing this vegetation coverage in the long-term approaches because the models are not considering them. But on the other hand, we are addressing in the short-term approach at least the coral reefs and the setting of the coast by trying to get the best possible the bathymetry data. So specifically, just to come back to that point, but because we have a lot of details in the project, but in this Maduro use case, we are going to try to derive bathymetry, coastal bathymetry, shallow water bathymetry, both from Sentinel-2, which is the usual approach in Earth observation, but also we'll try to do it from the very high resolution Pleiades data. So the same data that will be used to derive a digital elevation model will also be used to derive bathymetry. And all of that will be compared with the LiDAR, very good LiDAR data that's available for that setting. So it's a very interesting way of having much cheaper, let's say, data, much easier to get data in a remote location like this. And it's a very, of course, we know this is quite a critical data to have in such a risk estimation for that particular use case. Okay, I see, Ivan, you're also answering João, so I'm not sure if you want to answer in writing, but
yeah, in fact, I'm writing.
Maybe it's easier just to say.
Yeah, in fact, no. The idea is that we have done some work to take into account the effect of nature-based solution. Even it's not totally the focus of this project. In particular, we have done it with two models. One is wave watch tree, so for the wave effect, and the other is a Schleifer model. This is the hydrodynamic model, and we have done for the northern Adriatic Sea, which is one of the pilot of the use case of this project. I'm writing in the chat that the link to this paper that we have recently published, but maybe even. In particular, our application was related to the seagrass meadow in northern Adriatic Sea. We can also do some, when we will simulate the storm surge effect, we can also in this project try to see, let's say, something like a what-if scenario. To see what are the effect of the seagrass meadow to attenuate the surge, I think. And also having the landscape, the layout of the plants to see what are the optimal position could be something that could improve our modeling to see the attenuation in terms of surge. So yeah, we have done an effort on this way. I'm now writing in the chat this paper. Okay.
I actually see a lead here, Ivan, for maybe additional work, because as we just mentioned, doing this estimation of the effects of this nature-based solution within is not to be done within this project, but in the sense that we are not getting new Earth observation data specifically for that. So that's the idea here. We, of course, if you already have in the implemented model the data, then we can test, but that's, of course, something that you have already done in other projects. So it's not, one thing that could be here, very interesting here, but is not covered currently by EOatSEE, is to actually detect these seagrass meadows from space. So to map these seagrass meadows and then use them in the model. So try to have an idea of the seafloor and the biocenosis in the local setting, and try to use this in the model. This is, of course, not currently covered by EOatSEE because we are already doing so many things, but it's for sure something that we can include in the roadmap, the scientific roadmap, to be explored in the next few years.
Okay.
So,
yeah, in fact, all these like the last comments, they fit perfectly that roadmap, because there are this aspect of simulating vegetation is growing as well, and this there are not too many solutions that I'm aware of looking at this type of modeling, at least reduced complexity models that can look at erosion, probably interaction for flooding. I believe that's even the model Sphinx that Delta is showing here. I think it can do that, but in terms of evolution, morphological evolution, deposition, sediment transport, I'm not totally sure how is the state of that. But definitely these are questions, really, really important questions in terms of risk and vulnerability assessment, and also mitigation, adaptation measures that we're just discussing now. So very useful questions.
we have another 10 minutes. So we just got another one from Damian Moskalewski. I'm very sorry for mispronouncing. Do you consider validation of flooding extent prediction with geological records of coastal flooding? So it seems that this is addressing a different time scale. You want to comment on that, Pedro?
Yeah, probably difficult. That will probably require field work, which unfortunately we did not plan in the project. It would be amazing, but that would be the possible, at least, for example, in barriers or locations where we have overwashes, and we have the position of sediments in the back of barrier. You can somehow reconstruct past events and use that to validate the long-term time series. That will be very, very interesting. But unfortunately, we are not working on that type of tools. Let's say definitely, it's really interesting to bring these concepts, this knowledge from coastal geomorphology into together, because again, as the in situ observations together with all these observations, they are useful. But yeah, you are right when you're saying there are other also types of observations, such as geological records that can be used to validate this type of events, and this is something probably is totally on the side of when people think about to do this. So it's definitely something could add to the long-term assessments, but not really addressing this. Yeah, if you have suggestions regarding this, if you know existing data sets, I'm not sure if this is something easy to get, because this normally is very site-specific, done for specific projects. But any information regarding that type of observations are useful. But from our side, from what we are going to do and address, we are not considering it.
Okay. Any other comment from partners also? Let's see. Okay, so maybe we can continue this discussion on the afternoon session, and we maybe can have a bit of a small break now, just before we go in the next one. Please feel free to make questions or make suggestions at any time. Don't worry about we are not in the even if it's regarding the previous session or it's regarding on other topics that we are not addressing here today, but that you think is relevant. That's exactly what we want. We want to go a little bit outside of the discussions we already have internally in the project. So any contribution like this one's now about nature-based solutions is really welcome, and we are very keen to receive your opinions and your criticisms also for the approach we're doing. It's quite a challenging project in the sense that we're trying to address these two different time scales, the short term and the long term, with similar tools in a way that they can actually be compared. So we are implementing these simplified models, but we want to, of course, see the results, then confront these results with the results that we get from high resolution modeling, and to understand better how these two different approaches can be compared and used together. So any insight in that subject would be very much appreciated. So I suggest we break for another 10 to 15 minutes, and we reconvene here at 11:25 to 11:30. So let's try to be here at 11:30 most. So and then Pedro can start exactly at 11:30. So we do this short break now, and please keep on attending this and make sure that to be back at 11:30. Welcome back. Thank you for keeping in the session. We still have around 50 people watching here through this Zoom webinar, but also we have another 50 watching through the YouTube channel. So it's again a very nice audience, and we expect to get your feedback and your criticism during this presentation. So please feel free to put your questions in the chat, but especially to raise your hand and talk to us, and maybe we can give you the floor so you can have more interactive conversations and discussions, and maybe it's a bit more interesting and easier to explain your points and explain your criticisms by asking directly to Pedro and for me and the other members of the EOatSEE consortium. So without any more explanations, let's progress in this workshop with our third science case, which is focused on process understanding. And here our challenge is to focus on how nearshore morphology dynamic response and the cascade effect of extreme sea level events impact the long-term coastal evolution. So for that, we're going to have another nice review and presentation of our proposed approach by Pedro Meida. Pedro, please, the floor is yours.
Okay. So this final science case related to process understanding is trying to already using these tools presented before, in particular with these long-term tools to look into more specific process in a way that we are exploring these tools not only to develop the solutions, which is then one of the most important aspects of these developments, but also we are exploring these tools to improve our knowledge and to improve to give a contribution to science. So the same structure as before. I'm going to skip this slide and go directly to this slide regarding the challenge. And in this case, the overarching challenge, as Pedro just mentioning, is the long-term morphological response to extreme sea levels, and how these extreme sea levels also can promote somehow a cascade effect on a long-term coastal evolution. But at the same time, also this process will affect, since we presented before, there are feedback between extreme sea levels and coastal response, but also there are feedback from the response of the coast into the vulnerability to flooding. So all these processes are interconnected, and it is interesting to also use these data sets to explore a little bit more these interconnections, and also the drivers of these interconnections. So for this approach, we will use the long-term time series, as I just presented before, and somehow the justification or the reason why we're trying to bring this approach and make efforts to demonstrate that this approach potentially is more realistic is because most of the global scale assessments of flooding vulnerability were built, or even future flooding scenarios were built using the coastal morphology as a static approach. So basically all these components are simulated using a simplified also assessment of the wave contribution. The wave run-up is simplified by assuming a slope of the coast, and then also comparing it in some of these previous studies, comparing it with the coastal morphology. This type of assessment provides already a very useful and very important insights into into what is the state of the state and trends of extreme sea level events, and also how the coastal areas are being threatened by this process. However, as we discussed it, we presented or discussed it before, the coastal morphology responds typically to an extreme event by maintaining the equilibrium to this new hydrodynamic condition by mobilizing sediment from the upper part of the beach to the lower part of the beach. Typically, this is the new equilibrium established, and then following this type of adaptation, there is another adaptation when the prevailing conditions become less energetic, and then there is a recovery in the transfer of sediment from the lower part of the beach to the upper part of the beach. These cycles of erosion and recovery take place every year, every season. They are mostly induced by seasonal changes in the wave climate, and the long-term equilibrium is affected by this. In addition to this, there are other important processes that also affect this long-term equilibrium, such as the sediment balance, which is a crucial aspect, the sea level rise, the land subsidence, long-term process, but also the change in wave storminess. So from all of this process, the one that probably can promote more dramatic changes in a short period of time are the storminess and the storm wave climate. And we have quite good examples, recent examples of this statement. An example is the year of 2000, the winter of 2013-2014, that was found to be one of the most energetic wave records on UK. And observations from the shoreline indicate, and also modeling prediction using the force model, show that there was a displacement of the shoreline due to this winter. So there was a sequence of storms. So it's not a single storm. Sometimes a single storm can promote a significant shoreline displacement, but in this case was more than that. It was a sequence of very extreme storms that promote a dramatic displacement of this shoreline position, which affected over the time, and this displacement was never reestablished again. So there is this a clear indication that a single season can affect and can have a cascade effect, because then all the next storms, all the next years can have a let's say a different equilibrium and different response to the incoming storms. So this basically demonstrates the importance of looking at storminess, and that's one of the challenges that we want to address within this science case. So to understand how subsequent short-term storms, extreme sea level events, affect the coastal morphology evolution over long time scales. And then when we look at longer time scales, we have the other contributions that also take place, such as the sea level rise and, for example, land subsidence. So in order to understand what are the processes that mostly contribute to long-term coastal morphological evolution, we have to integrate all this into the simulations, and that's why we choose. So far, we choose this model to integrate. This is an example of how sea level can be integrated into the simulations, and, for example, assess the difference of the response of the coast using sea level rise or not considering it. So this can be a way to assess also the land subsidence, and this is something we want to address in this project, to try to understand the different factors and what's the contribution of this different process into the long-term evolution of the coast that at the end we will feed back also in the flooding vulnerability. So some of the solutions that we also want to integrate in this type of analysis are the land subsidence rates computed from advanced interferometry. There are available data sets for all Europe, but there are also expertise in the project, Telespacio, to compute, to analyze and extract this information from other locations that this data set does not exist, as for example in the north of Madagascar. And we use shoreline derived from satellite to evaluate and somehow validate, calibrate the model predictions. So the tools used to this objective will be the linear summation and the reduced complexity modeling approach. The fact we use the tool is also give us the opportunity to compare if we use the dynamic response of the coast or not use it. And so for that reason, we maintain these two approaches together. The storm hazard index will be used to give us an indicator of the hazards induced by these different extreme sea level events. And then we also add historical storminess analysis, specifically to understand some properties that are very important when we discuss the impact in the morphological impact at the coast. So, for example, intensity, but also the duration of the storm. It's quite important in terms of the time necessary to the beach reach a new equilibrium. The intensity can also play an important role in terms of erosion, depending on the equilibrium of the state of the beach. And then also aspects such as clustering. There are interdependence between storms and the frequency of this event. So this will allow us to also understand not only at specific events the impacts and understanding what is causing these impacts, but also explore the long-term aspects that relate these two processes, the long-term aspects that indicates the trends of storminess, but also relate that with the hazards. So basically, this will be performed using extreme sea level data sets. And basically, at the end, also we will explore the link between these two, let's say, storminess indicators and erosion and flooding hazard indicators. So the application of this approach will be at any sandy exposed coastal environment that we have identified within the project. Possibly we will add other sites. It depends on the data set availability, on the geomorphological condition, if it fits the model capabilities to be applied. And the objectives of this science case is to analyze how subsequent short-term extreme sea level events affect the coastal morphological evolution over the long time scales. What is the different contribution of storminess, sea level rise, and land subsidies to flooding? So by computing and integrating this process into the model, we are able also to separate somehow these different components and demonstrate what are the key factors. And finally, also with this work, we will try to demonstrate the potential of applying the similar framework at a large spatial scale. So can we apply this elsewhere where sandy beaches or exposed environments? Does this improve the previous assessments of flooding or even morphological evolution? This is something we want to assess. So the use cases and advanced science tools. Most of this was explained already before in the previous presentation. The addition of this in this analysis will be the inclusion of the land subsidence in some of the cases, but for the remaining parts of the data sets to be used will be essentially the same type of inputs, combining satellite information, windcast wave data, and modeling the storm surge data as well. The approach for this science case is to compute the long-term, already mentioned before, long-term extreme sea level time series, compute as well, mentioned before, the storm hazard index, analyze the historical storminess, and identify the contributions of the different drivers, and then also at the same time evaluate the potential of applying this similar framework elsewhere. Okay, and for this is the last part of the science cases. I mean, the same as before. Maybe if you want to just even to talk instead of writing, just to give comments on this, all these aspects that were presented. There are many things to learn and to improve. We are presenting here an approach using some specific solutions that we identified with the literature review, with by knowing what's the different type of solutions, even for example for the reduced complexity models, the existing solutions, and what we can bring with this particular one. What is interesting with this particular one is the fact that it changed the beach profile and considers the features of the beach profile, which can then be important when we are assessing the flooding. So if we are only interested in looking at shoreline displacement, possibly there will be other solutions that could be more interesting. But if we are looking to flooding, and this becomes more interesting because then you have feedback in the morphology. And in addition to that, this although we presented here somehow separated solutions, there is also a possibility of integrating solutions, so that instead of using numerical models separated from this type of models, probably there is also possibility to combine them and to somehow transform more in a more agile way the way we can get the hazards and calculate the hazards at the coast. So for me, that's it for the presentation. I will turn off my microphone.
Yes, thanks, Pedro. So once again, we welcome any comments, contributions, user needs, or maybe even describe a little of your own experience when addressing similar issues. So we would love to have to hear you talk also, so to hear your voice. So please raise your hand if you can maybe provide any testimony or talk a little bit about your own experience dealing with these challenges that we are raising here. I think, well, of course, we are focused now on this process understanding. So basically the cascade effect and the dynamic response from morphological setting. But of course, if you have also questions or comments about the previous presentations, we are also open to discuss those. I see we have people from all over the world, so probably a lot of you are now not in the ideal time zone for this, but anyway, we are really interested in your experience.
I've seen quickly the list of people, and I know there are people here expert in this, particularly expert in this aspect of storminess and relating this to more coastal evolution. So maybe I've seen a name from that is now in the UK that is very familiar. Maybe could give experience and the way he sees probably this type of analysis and modeling efforts. I'm not going to say his name, but if he doesn't say anything, I will say it.
Yeah. Okay. We also can hear from within the project partners and even his teams. Well, we have a first question from Francisco from LUNEC. Where is the Lisbon use case sandy coast exposed the environment? Because I think when you showed that you were showing the inner beaches, so the beaches within the Tagus estuary. So I guess
well, it's we selected Carcavelos, which is, I would say, partially exposed. It's not totally sheltered, but yeah, we selected that site to test it in this project. For this type of modeling is actually also easy to relocate or even to increase the transits. In this case, we selected also because it's one of the storms, one of the sites that we could see or have some indication of the impact of the storm, for example, the storm Hercules. But ideally for this, it'd be a location where we have other data sets, historical data sets to compare, or observation of the storms. That will be the perfect scenario. The observations of storms and the quantifications of changes in the profile. But for now, we selected only the beach of Carcavelos.
Okay, we have another one from Professor Jimenez. He's asking exactly what we mean by cascading effects, because I think we've been repeating this expression, but Pedro, if you can provide a definition or our own internal definition at EOatSEE.
Well, it's a kind of a language more than actually a definition, but the cascade effect is somehow what we observe here in the sense that a specific group of storms can change the sequence and the evolution of the system. So if we have one year such as this one, and if we have others, we will create a cascade. So we'll create different levels of shoreline displacement that will continue over the time. That's more or less let's say the way I call it cascade. So is that as a feedback in the sequence and in the long-term evolution, and this is possibly also to somehow convert into a more conceptual aspect, because the displacement of the shoreline in a situation like this, and if you have in a long-term time series stability or somehow another equilibrium maintaining that other level. So as we see here, there was a previous level of stability in the shoreline, there was a displacement, there is another level maintaining more or less over the time. So this somehow these displacements and these cascades, if this is observed over the time, is possibly to somehow convert more into a definition.
Yes, we have a comment from an answer from Professor Jimenez. He's saying that he would not personally call it cascading, but it's just a matter of nomenclature, of course. So it's still something that we might change during the project. Let's say the concept or the name of this concept, but we are really trying to address this effect of subsequent storms and accumulative impact on the coastal environment. As we know, it depends on the current status of these sandy beaches. It's very important for the actual effect that a new storm will have on it. So as we get more and more storms, so increase the frequency of this storm. So not only the let's say the intensity, but also the frequency of them are being increased, as we have several results from other scientific studies already indicating that. Then of course we need to focus even more on this aspect.
Sure. Thank you. I think it's definitely something to take in consideration. I mean, you are using the right name to address this particular, let's say, behavior, geomorphological behavior. And so we definitely will consider that and try to use the, let's say, the most pertinent or adequate nomenclature.
Yeah, maybe that's even something that we can go back to once we go to the roadmap workshop in a 1 year from now, almost 1 year from now, and we can go back to this and maybe adjust this nomenclature, because as Professor Jimenez is also agreeing now, this is quite important that we consider these effects, which are in many cases not so much considered in the current approach for the long-term coastal evolution studies. So for sure, as this gets more and more important, we might get better nomenclature, let's say, more well-defined concept.
Sorry, Pedro. Pedro and Pedro, we have Diogo Mendes that wants to participate. He raised his hand. I'll allow him to talk. Is that okay?
Sure.
Excellent, please.
Okay, Diogo, you can talk now.
Yeah, thank you, Pedro and Pedro, for this workshop and for these projects regarding Earth observation. I have two questions. The first question is more scientific question, is that how do you plan to take into account longshore variability in your analysis? And the second one is more about the tool that you aim to develop to predict the future coastline evolution. Since I work in a consultancy company, EOatSEE, my question is, how do you plan to account for different human intervention scenarios, such as, for example, beach nourishment, for the future coastline projection? Thank you.
Thank you very much, Diogo, for your intervention and for the questions. The model force is it considers the sediment balance, considering cross-shore and long-shore. It's possible to somehow input information. It's not totally explicit, but there is an argument. There is a parameter that considers the longshore influence, and I know that Mark is also working on this. Has been working in terms of integrating like a shoreline online model together with this. So that will be a really interesting advancement if this all comes together. So hopefully, and very importantly, as you mentioned, longshore sediment balances are extremely important in all these subjects. If you just of course, if you have an invaded beaches, which somehow is a closed cell, coastal cell, probably you'll have a dominance of cross-shore process, not so much longshore. But in any way, the two, let's say, components must be considered. In terms of the solutions you mentioned, this is something it's not really discussed in terms of solutions itself. I think everyone here involved in the project has already several solutions, existing solutions available, and probably be somehow easy for them even to answer to this question. I'm not so experienced in that as them. But definitely this is something extremely important. We have identified early user adopters, which is a way to already involve decision makers that can actually profit from the use of these solutions. Since we are going to demonstrate the solutions and potentially co-design or discuss some of these tipping points, some of the requirements, because we also will have to integrate their requirements into the roadmap of the project. So that will be definitely an opportunity also to somehow validate some of these solutions. And then the let's say the roadmap of transforming these let's say solutions, but still open and scientific, more orientated solutions into something more practical. It's something that will take another level of discussions or a level of assessments, and I don't really know how to answer to directly to that question. But definitely the whole effort and it's to accomplish that, to somehow try to bring science together, but at the same time to develop the tools that could be applied and transferred to society or to private companies as well.
So maybe just to complement a little bit that answer, Pedro, just to mention that we are using an exploitation platform, a Earth observation exploitation platform to integrate these data sets and to integrate this processing, this algorithm for this model. So we will be implementing these algorithms in a cloud environment through a Docker organized implementation. So in a sense, it's kind of ready to be deployed as a solution, but of course, like Pedro said, it depends a lot on the feedback that we get from the early adopters, from the scientific community, so from all the community that will be engaged in the project. Once we have this feedback, and of course we make the necessary adjustments, we for sure can conceive to develop more practical solutions and something that can be readily used by anyone into other locations. So for sure, this is within the objectives of the project, but the actual provision of the solution is probably be left for the roadmap of additional actions that will follow up the project. So I guess you have someone else, Moutinho, to talk.
Yeah, I guess we had somebody else, but I mean, he lowered his hand, so we have another questions. We better continue the written questions.
Okay. Okay, so we got another one from, I'm gonna mispronounce this for sure, so I apologize in advance. Zuzia Stroinovsky. Are the nearshore components such as kelp beds also considered? It probably doesn't have a big impact on large-scale storm events, but they do absorb notable amount of wave energy. So indeed, this is, I think, a bit related to the question we had before regarding natural-based solutions. Of course, in this case, it's not an engineering solution; it's just a natural environment. But it's maybe you can consider answer a little bit on this topic, Pedro. Please.
Yeah, I think it was just in line what we discussed before. Some of the short-term solutions here in the project, as Ivan was commenting, Tony, there are solutions for short-term that probably can look at these aspects. We didn't identify specifically sites where this could be addressed. I think it's really interesting and very important as well. But I believe the solution, the modeling solutions, mainly the downscaling numerical models, in some of the cases are the methods or the technology and the solutions exist and could be performed. It's just at least for the moment we did not explore. For example, this is more a topic related with adaptation mitigation. So if we want to see scenarios, if we do this modification of the bottom and put different types of vegetation or something that changes the friction, it could be done and could make all the sense if we had a clear vision to promote adaptation measures. That will be definitely the way to go. But the way we have established this project is to look into science and also solutions, but we have not identified specifically the tools, for example, to measure this type of environments, to assess the location or even the depth of this type of vegetation, how much they grow, or because they are also dynamic. So there are a lot of aspects that would require also from observations that we did not add let's say probably the expertise. I wouldn't say the expertise, but we are not focused. But I mean, I'll leave also to Ivan if he wants to add, and Tony and others to comment on this, and maybe also comment on the tools they have to perform this type of analysis. But for the moment, it's something we are not considering directly.
Well, just to add, yeah, I agree with Pedro. Just to add that maybe other type of vegetation, mangrove in different areas that are impacted by are covered by vegetation that could largely attenuate the wave motion and the sea level, the surge. Then it became irrelevant. In this specific test case, we could account this, but it's a limited respect to the total amount of surge that you have and the other component that could attenuate.
Okay, thanks, Ivan. Thanks, Pedro. We have another question from Laura David. She's asking if this product will be public accessible, and also if we are focusing on or we're considering different IPCC sea level rise scenarios for the future projections. So these are two very separate questions. So first, I think the first one, yes. My simple answer is yes. The products from EOatSEE will be publicly accessible, even because this is a condition for an ESA contract, that all the tools are going to be open data, open tools. So the exception for this is the numerical modeling setup that we have prior to the project. So this must be clear. Of course, we have this numerical modeling activities already before the project that we are making sure to take the best out of them, to make use of those results. But of course, the results from these activities and the results from the validation data and input data that is associated with this high resolution numerical model setups, this is not going to be available, unfortunately. Of course, the results of comparisons between different setups using EO data and not using EO data, of course, this will be shared. And all the results from the long-term modeling tools will for sure be shared. Most of the data sets being used in the project are already public. So this is we are just maybe shining more light on them and highlighting the potential use of these data sets. I think that's the advantage of the project, but most of those data sets are already open, and even some of the tools that we have are already open, like for instance the shoreline monitoring tool, the CEST, that Pedro mentioned before. This is a totally open and free to use tool. So let us know if you got interested in any of the input data sets or the validation data sets that were mentioned, and we can for sure point out the direction if they are free. But in terms of the actual products from the project, they will also be shared with the community, and we hope that this helps to scale this results for much more scientific work. That's really one of the key objectives of the project, to provide these results so that people can then derive more scientific results from it. The second questions about future projections. So maybe someone from Doutares could address that, because it's really on their side, and I know that they have a very interesting proposition to compare with the previous work that they have performed.
Yes, if Tony doesn't reply, then I will do it. Marieke from Doutares. So we have the global title search model. With this, we looked previously at reanalysis data. And indeed, also we can also look into these newer scenarios. So run the global title search model with the new scenarios. So that's let's say the water level from a search model. There we can do some work, and I think that was also foreseen in the project. I'd have to look that up. That's more Tony.
Yeah, that's sorry. Yes, that's right. The comparisons we're going to do is the work that Doutares has done for the IPCC, which also includes global modeling of water levels for both CMIP5 and CMIP6. Sorry for the abbreviations, but anyway, the newest climate predictions and the newest climate models. So we have indeed run our global tidal model for historical actual storm surges, and for 100 years into the future under the various climate changes. And they are the let's say the predicted changes to storm surges and water levels around the globe, which have been published by IPCC. And what we want, and they of course are very global by the very nature of our global tidal model. And so the objective of this study is then to see what we can obtain closer to the coast with the Earth observation, that may be, to look at what differences there may be, and to try and describe what those differences are, and how Earth observation can help us at that smaller local scale compared to the very global scale approaches that IPCC is using. So that's the approach that we're trying to verify and to validate, to take us one step further in the science case towards better understanding these historical trends and future trends closer to the coasts.
Okay, thank you very much, Tony. So once again, Mylene Irizaki has another question regarding the cascading effects. So actually, she's more providing a suggestion here. So she's saying that this cascading effect could also be explored from the operational forecasting perspective. So after a storm, this eroded coastal area could, of course, be much more vulnerable to a subsequent storm. Thanks, Mylene. That's exactly what we mean by these cascading effects, which, of course, we will review this nomenclature. So Earth observation could then provide updated initial conditions for this flood erosion model. when used operationally, potentially improving the forecast of the coastal impacts as the subsequent storm. So indeed, that's what we want to provide. Of course, as a first approach, we will try to provide this within the project use cases and try to validate it scientifically. But indeed, as I mentioned in the very first presentation of today, we have another activity which is trying to transfer these results for society. So whatever we have an operational forecasting model, and it's the case at least for the North Adriatic location, but also in some of the other use cases that we have, we will try to implement this new approach, and we'll try to show each time that we start a simulation of a forecast of a new extreme event. Make sure that we have the let's say the closest possible, the best possible representation of the current morphological setting. I think this is going to be really a step change in the forecast of these events, especially regarding their impacts. So I'm not sure we are going to accomplish this in the project, but we for sure are going to try it and evaluate in some of our specific use cases, and that's where the early adopters' feedback and contribution will be very, very valuable to see how much these changes and this innovation can affect the results and impact their planning, their decision making. I don't know if anyone else from the consortium want to complement that.
Then I can comment. Not just a comment, not totally from the side of let's say what we are going to do in the project. We have, because we have let's say specific time, specific objectives, and we have somehow already defined some of the activities. But definitely this idea of integrating the different tools, I believe it's really the way to go, because, for example, even this type of modeling, reduced complexity modeling, it probably will not capture all the key, all the detailed factors that, and probably will give the first good guess of the changes, but probably we need some sort of adjustment and calibration along the time. So it's and in that way, the EO products and EO solutions, and that also applies to the other models, can come in place and provide an additional information that can perform this site-specific adjustments along the time. Of course, it's not, let's say, process-based solution. Is a more statistical or mathematical kind of a simulation or adaptation of the estimations, but it's something that definitely would then be useful to combine in an operational mode, so that you have fast simulations. You could have the information, the first guess information, but then you could also get a validation improvement with the continuous satellite observations. Not sure if we will, because this requires other tools rather than just models and data sets. It requires something in between to let's say to connect these things together, and we cannot do everything. So it's step by step, but definitely that I think that's something to look for.
Okay, I see we don't have any more questions in the list, but we still have another 10 minutes that we can use for discussion. And so again, I invite you to raise your hand and make your comments and your critics, maybe highlight some of our weak points of our proposal.
Yeah, it's interesting that if someone, nobody else says it, but I know that, at least from what I've seen, probably people here are from companies as well, and I would guess how, for example, in their consultancies look at this at this type of process. If they will, for example, if they are requested to do adaptation plans and these kind of things, what type of tools they normally use, and are they related with the ones or similar somehow to the ones here, and what are the problems they have also regarding that? That could be interesting to know as well from their side.
Okay, so I think people are still a bit shy or already hungry and going for lunch. So I don't know if we should get any other comments from within the project team or Isa. So what I can do is maybe make some comments regarding the afternoon session. So I'm taking a lot of notes during this conversation, and we want to go a little bit deeper into those questions, into those remarks. But of course, we are also going to be open for new ideas and new contributions. We might have different people on the afternoon session. As you know, this session is being recorded, available on YouTube. We will be following up with an invitation for you to subscribe to our newsletter from the project, so you are always up to date with the latest news and tools and data. So please try to be on this afternoon session. We want it to be a little bit more dynamic, with no presentations but just discussions. And let's try to make the best of this workshop to really make sure that we are doing all we can in the project, and that anything that we cannot do right now is already identified, and we will include that in the roadmap that we also will build during the project. Okay. I see Amadeo in the chat. So Amadeo, if you want to make any questions, we can give you the word, give you the floor. For sure, we want to hear from or a group of African researchers, that we have a lot of them. I can see a lot of them participating. So we for sure wanna understand better what are the pressing issues, what are the needs and specific needs that you might have that there.
Hello, Pedro. It would be nice to have Aristomenes Amadeo. He's the director of the weather services in São Tomé and Príncipe. So Amadeo, if you have any questions, if you want to understand how EOatSEE can help you out in São Tomé and Príncipe, just raise your hand and I will allow you to talk. Otherwise, you can write your questions or comment.
Indeed, that's quite interesting because Saint Tomé was a location that we actually considered when we were drafting the proposal for this project. So we, of course, it's quite an interesting location in terms of, well, science for coastal risks. You have low-lying environments in a very exposed location with maybe scarce data available. So that's a good combination for EOatSEE. We're trying to bring additional data, and we are trying to unleash these tools that can provide reliable estimates of coastal risks, even with scarce data. So taking advantage of this Earth observation, of course. At that point, we didn't progress with the use case, but of course there is still opportunity to address this. Some of these tools can be deployed quite quickly, quite easily. So I would say we're still open to provide some analysis if that's a local requirement. So Amadeo, please feel free to speak or even to contact us afterwards. We're very open and very interested in your remarks or your understanding your requirements. Okay, so if we don't want to have any urgent matters, I invite you all to come back to the afternoon session. We will have a lunch break right now, but we will reconvene at 1:30. So when we will start a discussion about reviewing this feedback that we got in the morning, but of course still being open to additional comments and additional criticism and all these different contributions that we can get from you. So I see one more question right now. Why find coast level? It's not very clear, and we have an anonymous attendee making a question, but it's not very clear for me. But yeah, Ibrahima. So Jose, maybe we have 2 more minutes. We have room for this last question. If you can give the floor, Jose, for Ibrahima.
Hi, Pedro. I already permitted Ibrahima to talk.
Yes, we can hear you, Ibrahima. Hello, we could hear you.
Yeah, I'm not hearing now.
You can talk, yeah. Ibrahima, can you? Hello, Ibrahima. We can't hear you, but I mean, talking is permitted.
Yeah, something's not working on his side probably. So yes, I think we need to close right now so people can get lunch in time for the afternoon session. But again, I thank you very much for the contributions. I think this was a very interesting, valuable session for the project. It for sure will help us to better define our objectives or work plan. So we are for sure going to make adjustments. But yes.
Is it okay?
Now we hear you, Ibrahima.
Sorry. Okay, good. Okay, as I said that I'm Ibrahim from Senegal. I'm not an expert in sea level rise, but I am very interested because I work on the coastal zone. I think I met Pedro once in 2017 in Senegal with Rafael Almar. So my question is, generally here we did some study on coastal vulnerability, and we use the coastal vulnerability indexes. So I would like to know if there are link, if your project plan to use this kind of indexes, or if you will use only model, and what are the advantages to use a model instead of coastal vulnerability indexes? Is it clear?
Yes, I listened. Sorry. Yeah, I think I remember you for sure. The field experiment, very good. Missing a lot Senegal and field experiments. That's something missing in this project. I don't know why. So to your question, now we are using models, yes, and they are fitted in some cases using different data sets or EO integrated, or even in situ observations that can feed the model to simulate the conditions of a specific extreme sea level event or a long-term time series. But then we convert the modeling results into indexes. That was the presentation just before this last one, where we are going to implement two types of indexes. One index that combines the flooding regimes that assess the flooding potential hazard, and also at the same time the erosion potential hazard, and combine that two information obtained from the models into a single index. So that is one. And the other one, it's the flooding extension and depth. So that is calculated also from the modeling simulations, and then we assess, we transform, let's say, that the information of the simulation into this other indicator. So yeah, it's we want to use as you in your study. I don't know specifically the indexes that you have used, but I guess somehow similar to the ones I just commented. I don't know if you want to comment to the type of indexes that you applied in Senegal. Was it in Saint-Louis?
No, not in Saint-Louis. It was in the Delta of Saloum in Fatick, in the south.
Okay.
So it was an index that used 6 variable, coastal shoreline, tide, wave, high, sea level rise. So it's like the Brun, it was the Brun and something like that. As I said, I was not the expert. I was in charge of analyzes the wave data and sea level rise, and to give it to the expert, because there was another postdoc who was in charge of doing SIG, but I'm not an expert in SIG for shoreline rate, something like that. So we was two. I was working on the ocean part and was working on satellite data. So I think I missed the first presentation due to the lack of time. So that's why I didn't see the first presentation.
So I think probably your index is a bit more to look into some specific aspects. I don't know, in this history environment, is it looking at the vulnerability or the condition of a certain ecosystem? Or what is then the application of this index?
You would like to see also the impact of sea level rise on coastal vulnerability.
Okay. So it's
so
like
we call it coastal vulnerability indexes of EOatSEE, something like that.
Okay.
Long time I did this, but now I don't remember.
Thanks. That's very interesting.
So thank you. Nice to
nice
to
to
see you online.
listen to you. I don't see you, but nice to listen to
Yeah,
you. Thank you
yeah.
for participating.
Okay.
Ibrahima, you can turn on your camera if you want to, for people to know. Yeah.
Have a quick look on
Hello,
Senegal.
I'm Ibrahima. It's okay?
Thank you.
Yes,
Yeah, I can see you perfectly.
Thanks a lot.
Yes.
Yeah, we're really this is really a global audience. It's really exciting that we have contributions from all over the world. So for sure we'll get back to you, Ibrahima. As Pedro mentioned, also most of these long-term results, we are planning to generate them also in some of the transacts that we're evaluating to the work from Rafael Almar. And so 2021. So that's some of those transacts. We know that a lot of work has been done in Senegal. So we for sure can try to produce generate some data and compare these results and try to understand the impact of the different models and implementations that Pedro has explained. So we for sure can come back to you. So we need to close the session. We are already 5 minutes past the time, but I just want to mention that Dr. Srikant, again, I'm sorry for mispronouncing, has offered to collaborate. So for sure, we'll be in touch with you to try to understand your needs and also try to maybe generate some results in Singapore where you're interested. So thanks a lot for the offer, for collaboration, and thank you all for coming and for there's very interesting discussions, very good contributions that we had, and we hope to see you back on the afternoon session. We might get some more people from the US maybe because of the time zones, and so we might get a little bit different audience and get and deepen a little bit of some of the discussions we had this morning. So without waiting any further, I will now invite you all to come back later at 1:30. So have a good lunch and we'll talk to you later. Thanks. Bye-bye.
Zé, mas isto está live.
Good afternoon, everyone. Hope you all have had a good lunch. Let's just wait another 3 minutes. So we have 5 after the time. So we have most of the people here. So just another 3 minutes and we'll start the session in the afternoon. Okay, thank you once again for reconvening for this afternoon session. As we planned, we want to explore in a little more detail some of the comments that were presented this morning, some of the feedback that we got regarding our approach But if you were not able to attend the morning session, please let us know if you have any other questions and issues and doubts. Maybe, of course, we can always go back to the presentations from the morning and show you some of the details if those are not clear. So the way that I will do this is to, during these morning sessions, we've been collecting this feedback from you, and we've been putting them out together in the Miro board. So that's what I'm going to present right now. And then we can try to discuss this, and then I hope that I get feedback from you again, and we can try to discuss these different issues. So I'm not sure if you're all familiar with Miro boards. This is just kind of a, let's say, a notice board that you can put different stick notes and different information. So what I got here, I have 3 boxes, one for each of the science cases that was presented by Pedro Almeida in the morning. And the yellow post-its here that we get are the feedback that we got, so the questions that we got from you. And then the green ones are the answers that were provided during the session. And the purple ones are the ones that we already have an idea that this is outside of the scope of this project, and that therefore it will be included in the scientific roadmap to be addressed in future opportunities. So that's a color code that I'm using here. So coming back to this first use case, we got a lot of comments. So I will try to address them one by one, but of course we will see which one will be more interesting. So here is where I really need your collaboration, your contribution, both from the consortium partners, but also from the audience. Whenever you can, please raise your hand or comment in the Q&A area, and we can include this new contributions here. Of course, the idea is to understand how these issues will be managed within EOatSEE. So we discussed this first comment that we got. We discussed it from during the session regarding representation of river contribution for these extreme sea level events. So we indeed, I didn't get the answer at that stage, but we got an answer in the Zoom meeting notes. But now I haven't translated here. But basically, what we're doing is we're addressing this issue in 2 of the project use cases: the one in Lisbon and the one in the North Adriatic region. And we are doing this by the conventional approach, using numerical modeling. So using the contribution that we already have in the implemented numerical modeling chains, but then trying to evaluate this also with EO data. So trying to validate whenever we get the opportunity in different places of the estuary. So I'm not sure if anyone could add any other discussion here. So regarding river contributions, of course, some projects have been exploring the possibility to actually measure discharge using satellite altimetry, which is not the focus here. So if we are able to do some comparisons, we are going to do it, but it's not really the focus. So I'm not sure if maybe
I think this is in I mean this is somehow covered by some of the use cases that we presented. So considering that you raised this question, and I think what we answered was that we have the cases from CMCC and in North Adriatic, and also the Lisbon. So I think somehow this is already in the objective.
Okay, so we shall not spend too much time here. Let's go for the. Of course, there is already a connection here. As you can see, there is a comment from Lenek, from Francisco, saying that they have already done a lot of work on regarding relating storm surge to river discharge. So this is quite fortunate, and for sure we'll be looking for this literature, but also we'll probably be calling you directly, Francisco, Andrea, and trying to understand it better. Again, Francisco also comments about Mohi and Swan coupling. I think that's the case, Pedro, in the Lisbon use case.
Yes. Yeah, that interaction, that two-way interaction, we have been discussing, and I think this is the way we are implementing it. So the Mohit provides the hydrodynamics, tides, at least, and the river flow discharge, and the currents that creates, and also then you interact that information with the waves, but also then the waves interact with this. I think that's what I mean, and I think what we are implementing.
Exactly. So that's, of course, the idea is to deal with these non-linear interactions, which is something that CMCC has also been very keen in their use cases. So I think for sure for the North Adriatic use case, we will also have the same kind of setup. I'm not sure if Ivan or
yes, Giovanni Copini.
Hi, Giovanni.
I confirm that we will study this, both the coupling and the effect of the river on the sea level.
Excellent. So if we don't have if we have any other comment coming from the audience, I would be keen to address those. Okay, so let's move to a bit of other topics that were also explored. So wave run-up, that was a quite interesting discussion that we had. So I'm going to show here also the answer from Tony Means from Dotares, because this was, of course, in the chat in the Zoom. So maybe not everybody was able to see this. So indeed, we will try to incorporate this wave setup in the current modeling approaches we have. XBinch for sure try to incorporate that. But as we know, it also is a factor from the input data that we are forcing this with. So that's where EO comes in handy, because we can compare this forcing in the base of the active beach profile from what we get from these boundary conditions coming from different numerical models, but also boundary conditions coming from Earth observation. So that's where we can do some comparisons, at least with this data. Again, when looking at the very short time scales, Earth observation still lacks the temporal resolution to provide these boundary conditions. But of course, we can always compare this time series and understand what's happening.
I think Pedro, Giovanni speaking.
Please, Giovanni.
I'm not sure. Was a satellite expert speaking about boundary condition from EO data, because I think it's a bit overestimating the capacity. Maybe because, as you are saying, for boundary condition we need continuous fields in space. Well, in space we can, but in time also. So maybe it's better to think about validation using or comparison and validation using EO data more than providing boundary conditions. I don't see how we can run a model.
No, you're totally right, Giovanni. That's exactly what I meant. At this stage, with high resolution, short-term approach, then we are really looking at just comparing the data and not using it as boundary condition. It's just comparing it.
I agree.
So kind of evaluating the quality of the boundary condition that you are already using, coming from low resolution numerical models. So this is what we can do with the current stage of Earth observation data. It's just to compare. Then when you go to the long-term approach, is a different story, but here on the short term is just to compare the data. But here, the thing is that the question was actually about wave run-up and not wave setup. So far we've been talking about this, but it's mostly about wave setup. Run-up, as we know, is very much controlled by the coastal morphology. So it's a much more complex process, I would say, to simulate in terms of accuracy, because of course your topography models must be very, very precise. The type of substrate, of course, will be critical here also for the percolation of water. So it's quite a complicated issue. So I don't think we can get it from Earth observation. But nevertheless, we might try to explore the limits of this, how much we can evaluate and attribute to wave run up and not only to set up.
Yeah, it's I think it's difficult. I think this the intention of having setup, it's interesting because it's a component, actually a component of run-up. We have both the setup and the swash, but it's a more persistent component. So it's basically, if you want to look at important flooding, important hazard flooding, the setup should be considered more than the other component, the swash, because the swash, they could promote some sort of overtopping, punctually overtopping, but it doesn't mean that it will affect or will produce a significant inundation or flooding. And setup, no, setup, it means that for a persistent amount of time, the water level at the coast will be at that level, and that is really that's really important. But I mean, I think here we are entering something that has not been explored as much. I'm not sure if we can get some sort of information from the products that were presented, for example, from CLS, even the measurements at 300 meters at the coast, because they are single pass, and they are not continuous over that same region. Definitely, it's a really interesting thing and really important, as authors mentioned, as the Marianne. But also she's commenting, and one aspect that she's mentioning here is the if we are somehow improving the beach geometry, or what I think she means by this is, for example, for run up, the slope, it's the typical morphological parameter used to include in the empirical equations. But also in the numerical modeling studies, this has been somehow proved that the slope in the active zone of the profile is a key aspect that improves, affects the run-up. So I think she's more asking if we are bringing something new about the morphology, probably. I think this is, at the point is done, but a specific one location. So in terms of a new contribution to run-up by bringing something really new, I don't think we are doing that explicitly. Maybe some of these data sets can contribute.
But indeed, the focus was on beach geometry, which of course it's related to run-up, as Tony has answered here. Also, of course, it's very dependent on this beach geometry. And I think it's a good time to talk about the limitations of Earth observation for topography work, because that's exactly what we propose for one of the use cases we have. Of course, doing topography or doing anything with very high resolution data entitles costs, because this data has a price. and entitles commissioning the satellite to take the images exactly in the way that we need them. In this case, it will be 3 stereo Pleiades images that we're going to use, especially in Maduro et al. Use case. And the idea is that we use there because, of course, topography is very critical there. And it's a very hard place to get data. It's quite remote and quite difficult to survey. So, but on the other hand, we have an opportunity because in these specific islands, we have a LiDAR survey to use as a validation data. But then there are all thousands of other islands in which you don't have LiDAR. So using TriStar Pleiades to derive digital elevation models would be really interesting and a cheaper way to get this data. Nevertheless, not only it costs money, but also it comes with some limitations. So from what I understand, we are around 1 meter of let's say precision in those results. So in the vertical elevation. So as you can imagine, that for run up is quite complicated. It's not enough to clearly to make sure that you're capturing the run up effect very precisely. So I think we are still not there in a place where we can use satellite data to have a precise enough topography that we can simulate run up with confidence. So this is a bit of the limitations, but maybe it's also an opportunity for having a roadmap to include this in the roadmap, because we need more accurate.
I think Pedro, just to add to this, I think we need actually something that is very useful is to have the quantification of uncertainty. So when we talk about these different data sets, the global dams and everything, Copernicus dams, you have all kinds that go from 1 meter spatial resolution to 30 meters or more. But in terms of flooding extension, and we have indexes to evaluate that, what's the difference of
indeed.
But then that's something we could possibly do. Not sure to which extent, but definitely I think to assess the uncertainties is really important indicator.
Yeah, for sure, Pedro. But this is included for sure in EOatSEE. I think in the first use case here in predictability, we are comparing the data itself, the topography and bathymetry data, with the validation data that we have, and then in the second use case, we use the flooding index map so that we get the flood extension map, and we do it with both approaches, with the LiDAR data, but also with the data from EO, and then we can really evaluate these uncertainties. So for sure, this is something that we need to have a better idea of the uncertainties, but we already can conceive that we will probably, to go all the way to run up, we will probably need better data with less uncertainty. But of course,
Pedro,
yes.
Just sorry to interrupt you, Maya Lin maybe contribute because she asked to. I'd like to allow her to talk. She has been waiting for you. Can I allow her to talk? So
please interrupt me anytime, Jose.
Yeah,
no worries.
Sorry about that.
Okay, can you hear me?
Yes.
Yes.
All right, great. Yeah, in the end, you have actually by yourselves interpreted my comment in many ways that I was also thinking in that way. So in the end, what I wanted to discuss here many ways in which Earth observations could help directly or indirectly measure wave run-up, which contains wave setup, according to the definition you gave this morning. And I understand that the swash is, well, maybe something else. The wave setup is something more tangible and that we care more about in terms of when it comes to flooding and flood hazards. And I was wondering if there is a direct way to measure this through Earth observations, because we really struggle to measure wave setup from tide gauges, for example, because normally they're in sheltered locations where wave setup is not present. That's let's say the first most direct item. And then how Earth observations could help indirectly would be, for me, indeed, what you were commenting by, for example, characterizing better the beach geometry, so that then we can include this information either in empirical relationships, empirical parameterizations for wave setup, which if not dissipative conditions, they also rely on the beach slope. So it could help indirectly in that way, or to directly fit models like XBeach, which compute numerically the setup and run up given the profile. But I didn't know what kind of resolutions we could get with Earth observations to characterize the beach profile. So those were all the angles that I was thinking of. And then there was the angle of uncertainty, which you just commented as well. But maybe I would want to add something else there, which is with Earth, well, there is the beach profile, but there's also the variability of the beach profile, which you could observe and therefore include this in the predictions as well as natural variability, let's say, but that adds to the uncertainty of the flood that you get, of the cascading impact on the forcing, let's say, and then the flood.
Excellent. Thanks very much, Maylin, for these considerations. This is interesting for sure. I think the first thing to address is this, is there a direct way to measure this wave setup? So for sure, that's something that we are trying to address in the project. So as you can see, some of the simplified models, we want to try to implement wave data on the base of the active profile. So it's already answered you. No, there's no direct way, at least in our approach. And the reason for that is that probably you are aware there are two main limitations for Earth observation data on waves. Basically, not, in this case, it's not waves, it's altimetry, but of course, wave data would also be useful. But the limitations are the same, temporal resolution and distance from the coast. So typically we get temporal resolutions on the order of 10 days. In some cases a little less, 7, in some cases a little more, until a month. So of course we can combine different sensors as long as they are in the same track. Fortunately, this is the case for the let's say TOPEX legacy sensors. So beyond TOPEX, we have Sentinel-3 and Sentinel-6 now going through the same tracks, so we can actually combine this data and try to better improve this temporal resolution. Nevertheless, it's not enough for short-term modeling. We are aware it's not good enough. The second limitation is regarding the distance from the coast, and that's where maybe we have better news, because on the most recent work that has been done, in which a lot of those CLS is involved. Also, the ESA team that is managing this project is also involved with a lot of those initiatives. They are doing this along track altimetry data, extracting data along track, and that allows, as long as the tracks are almost perpendicular to the coast, we can get very close, and when I mean very close, it's 100 meters order, or a couple hundred meters of how close. So you can think that as long as you don't have a too abrupt beach profile, you can probably get all the way to the base of the active profile. So it depends on the location for sure, because it has to have this specific orientation in regards to the satellite track, and it has to be evaluated. So that's for sure one of the key topics that we are addressing here. So we are going to do in the short term, like I said, we're just going to extract this data and compare to the data that we are currently using as a boundary condition in the models. But for long term, that's where we really think that we can use the data as an input for those, let's say, reduced complexity modeling strategies that Pedro presented this morning. So I don't know, Pedro or even Mylene, if you want to complement.
No, thanks. I think this clarifies. And in any case, some information is better than nothing, right? So I think Earth observations has the potential to provide at least some level of information, say, for example, on the beach geometry, where no other local information exists. And in particular for wave setup, even at using empirical relationships that in the end rely on beach slope, this information is generally lacking locally, even in Europe, where we have a lot of data for the coastline. And so we lack this critical information to give some estimate of the wave setup in the larger scales, let's say.
Yes, indeed. We are also trying to extract bathymetry data in different locations. So in that case, we are not looking only for very high resolution, but also for Sentinel-2 data. So that should also allow in very scarce, locations where data is very scarce, that could also be an option. But the main thing here is really trying to get to the limit of this altimetry data, how much close to the coast and how can we explore this data to the limit by combining different sensors, combining different data sets. So this is for sure within the scope of EOatSEE. You want to comment, Pedro, on that also?
Well, more or less. I mean, it's. I think this is there is no direct measurement. That's one thing for sure. I'm not totally convinced that if the altimetry will be better than, for example, even if you had high resolution imagery, high resolution and high temporal resolution, because if you want to capture this process, so as for example, it has been done in the past with let's say terrestrial remote sensing, using video imagery, you basically capture the information of the total water level, including the run-up, a long time, and using tide gauges, you can somehow understand what is and calculate the setup and run-up. So maybe one possible way, but then we are talking about putting complex things together. It's what also has been done to use, for example, in video imagery, reconstruction of the coastal topography, where you associate to a certain level of water the empirical relationships of setup and run up together. So if you give to that, for example, 2% of exceedance observed by 15 minutes of data or more, if you associate to that the wave heights, tide observations, you somehow indicate that line has a certain level, vertical level. And by doing that over the time, you can somehow reconstruct different contour levels. Maybe do somehow similar to this approach, you could get from, for example, shoreline positions, but then you would need more data sets, more data in terms of temporal resolution, that you could do the same processing, so that you could associate with each one of these lines an attempt to link the setup and the run-up, storm surge, and all the other processes that were occurring at the same time, and creating that specific line. You could then possibly find a way to get the setup. But this is too much, maybe too much, not too much going around, not really direct way, and maybe that's more useful to have a clear indication what would be the most direct way to get it, than actually inventing a lot of complex stuff to get it. So I think what we can do, and I think that will come, it's when we have the opportunity to test this very focused SAR data, very high resolution, high temporal spatial resolution, we can assess this and understand where we can reach and what are the limitations still. That's the only thing I want to say.
Okay, I like the idea about coastal video imagery, but like I said, it's getting too complex, and then we can leave it in the roadmap. As you can see, I put it as a roadmap note. So let's try to move to another topic. We have several to explore. We have a lot of time in the afternoon session, but let's not be too strict about timing. But just we want to also try to approach other topics. So this one is about the validation of the flood modeling by using some kind of detection of this flooding by observation. So indeed, this is planned. We want to perform this in probably 2 use cases, not only the one in Maduro, but for sure we can do it in the North Adriatic use case, where we already identified one in a flooding event. It's quite let's say again it's again the temporal resolution of Earth observation comes here as a limitation. So whenever we are doing this, of course we have to have the opportunity of having the image at the same time that we get the flooding. So at least on the most critical time of the flooding, that's the ideal situation, which is not so easy to get, let's say. But of course, there's a lot of people working with this at Copernicus Emergency Service. We will try to rely on the same data they generate to use this, but we also have capacity within the project partners to do it by ourselves. So this will be explored both on optical and SAR data. Of course, usually you don't get much from optical data because with storms you usually have clouds associated, but nevertheless we're going to look at that, trying to get the most out of it. So it's very much an opportunity thing. That's something that we need to do in the project. So we'll map all the extreme events that we have in different use cases, and then look at the flooding data and see if we can get that. So as you see, the answer from Deltar is here regarding Maduro. They don't have an inundation event. So while they simulated the event, they don't have a real one to look for in the satellite. So that's like of course this is a premise here. You need to have the flooding events for starts. So probably the North Adriatic use case is the best, is the one where we will actually be able to validate this. In the case of Maduro, this will be validated just with the numerical model, running the numerical model using the different data source, data coming from LiDAR and data coming from Earth observation. So that's how to evaluate. Mayalin, I see you still have your hand raised. I'm not sure you want to talk or you just...
No, sorry.
No worries. And just for notice, your mic is open also. So, but don't worry, just warning. Okay. So regarding the flooding, anyone has other comments or suggestions or criticism or similar work that you have performed? Okay. Actually, there was another part of your question here, Mylene, that I think it was not addressed because it's the attribution issue to for EO to help discern the contributions between fluvial and marine driven flooding. So it's something that we also had in the when we were discussing the river discharge. So again, it's something that we cannot do solely with EO. We will try to extract altimetry data in different parts of the estuary, and that can provide us some insight, some indication in that direction. But in the end, it's mostly through the modeling. I'm not sure if someone was trying to talk or just have a mic open.
Just maybe I think it's interesting to look back into this. Just even talking about the question before, I found that there was a tropical storm, Nangeka in 2015. I'm not sure if it was a typhoon or a large tropical storm, but I saw some pictures in the Marshall Islands. Maybe not really impressive flooding, but there are some flooding. So even though I think it's worth to check the data sets, these maps. I think these maps are available somehow in a service. If I'm not, I think it's in Commands. That is Copernicus. That has a service where you can check these maps. But I was just, I think it's worth to, well, everyone will have to do this exercise to look back into, to find, even for these altimetry data sets, to find the times we have data available to compare. So it's also worth for the flooding extension to look as much we can into the historical events and try to see if there is anyone that we can use.
Excellent, Pedro. So might have an opportunity there. Maybe we cannot have a flooding in the exact place where we have the numerical model implemented, but we can still test the flooding, let's say, assessment tool in a let's say an island environment. So we will need to see how to try to address that because it's really looking for opportunities to have the image at the same time of the event.
It's funny, this exercise of looking to the events that have data instead of just looking to the events and then get the data and use the data. And this is already an indication of how probably the temporal resolution, also the spatial, is still probably a limitation of these data sets.
Okay. So we have another issue that was raised by Professor Jimenez, and it's regarding, of course, compound flooding. At the time Pedro was still presenting, so in the end he finished the presentation by saying that yes, we are not addressing this compound flooding solely only with EO. We're actually getting the model there to get the necessary temporal resolution. So of course we need to combine solutions, and this project is all about combining solutions and not only exploring EO. But then he gives a very interesting suggestion here about looking at the flood extension before the actual coastal event. This is quite interesting because for sure these things can be associated. You can have very strong rains, and only after that you have a storm surge coming, and then it's where I used to live in a place in Brazil that had this all the time, so I pretty much recognize myself here. And so this is quite an interesting thing because it has to do with time scales. So we should for sure look at the couple of weeks before an extreme event, so that we understand if maybe something was happening on land before that. For sure, we don't have simulations of water basins or let's say underground water, but in this project, but we could do it in further projects, but this is something that we need to look at. I actually will put another note here regarding this to simulate underground waters.
Actually, this is process is defined in the literature as a precondition compound, where a previous event affects in time the consequent event that arrives. I think, yeah, I think this is really interesting. But maybe for the moment, I think the other temporal and spatial compounds are more likely that we can address with the setup of the cases we have, and the models and everything. But for this one, I think this one requires a bit more knowledge and tools to look at inland properties of not only land cover, but also modeling the infiltration, the saturation of the soil, propagation, and also the interaction with the urban water discharge. Is a interesting component of this compound, but probably would require a bit more tools inland. So that's only my comment about this.
That's what I mean, Pedro. I was probably thinking about Mohit already, because we know that Mohit can do this coupling of this underground water simulation. So, but of course, within the EOatSEE, one thing that we can do, and it doesn't take much effort to do, is just to check on these inundation maps from Copernicus and see if we have any inland inundation before this extreme event. So again, an opportunity here. So maybe we don't find anything, but maybe we can find something that's quite interesting. So thanks a lot, Professor Jimenez, for this comment. It was, I think, a good, a very interesting idea. So I have a last one here before we go to the next topic. And it's about in situ data. So, of course, the only in situ data that we are using in EOatSEE is the one that is already provided in the numerical models implementation. But for sure, we would benefit from additional data. So one thing that we can do here is really foster the collaboration with future project. With projects or institutions that can provide this data, because while we cannot do it within the project, for sure we would be interested in collaborating with this project, not only using the data, of course, but also providing our results, even for planning of this of the campaign. We all know that when you have a numerical modeling tool implemented, it's much easier to plan for the best possible survey campaign. So I think this is quite interesting. So with this, we close predictability. There's a comment here from Paula, but it's just so she can get the information later about the workshop. So yes, indeed, we are having this recording. So we are currently being broadcast at YouTube, and anyone can see the whole workshop. Before I go to the next topic, I want to address a comment from one of the attendees from Namibia. So I'm just gonna stick it here. So basically, he's asking if again about the outcomes of the project. So that's something that I mentioned before. indeed, we are fostering the use of these outputs by the whole scientific community. He's asking about IP issues. Well, like I said, anything that's going to be produced within the EOatSEE has no IP. It's mandatory for an ESA contract. We don't, well, of course, and it's not has no IP. Of course, it has IP. It's intellectual property, but it's just open. It's not something that any of the partners can charge for it. So, but this, of course, covers everything that's produced within the project. So I can say that, for instance, all the results from the extreme data set in these locations that we're exploring, this will all be shared. Also, a lot of the data sets, like I mentioned before, a lot of the input data sets, a lot of the tools that we are using, CEST and other tools that we are using are also already open and available for the community, and we are making sure that to highlight this. But also, I think some of the algorithms that we are developing, we can also, that the ones that are being developed within the project, for sure, can also be shared. So they could be applied in other regions if people are interested to do that. So yes, we are very keen to collaborate, and we are very keen to make the most possible impact of all the work that we're putting in the project. So feel free to reach out for us and ask specific requests, whatever you want to know. We are really keen to share the knowledge. I cannot see at the same time the list of participants, but I see that the Air Center has asked if Professor Jimenez wanted to talk a little bit more about the time frame issue before we move to the next one. I'm not sure Professor Jimenez is still here. Yes, he is, but maybe not available to talk. Okay, so maybe we can progress, and then of course you can always come back if needed. So the next set of comments is regarding the second challenge, risks and vulnerability. And let's start with this first one about citizen science. So this was already discussed during the project, but of course we are very open to more suggestions here. How citizen science will be used. So we are thinking about basically two things. One is to maybe three here. One is to consult with these local stakeholders to understand better the tipping points for this specific use case. We want to understand what are the changes that becomes irreversible, specifically in terms of human infrastructure. Of course, in the terms of the natural setting, we can also learn a lot from local stakeholders. But with infrastructure, then we really have to rely on them to tell us what can be rebuilt, what cannot be rebuilt, so what's more valuable. So for vulnerability, for sure, we need the consultation effort. Maybe one thing that's more core citizen science is the analysis of social media. So that's something that we are going to do when we define one thing that we call internally as a catalog of events, which is just a calendar with the dates of each of the extreme events that we want to try to have another look, try to have a closer look. So once we have this for each use case, then we can try to go on Twitter, go on social media, and try to see if there was a trending topic at that stage, and what kind of information can we extract from that. This is not like a core activity of EOatSEE, but it's not something that was. We don't have a specific work package or a specific partner dedicated to this, but it's something that we're going to try. So it will come from each of the pilot case leaders to try to assess if any additional information can be raised from social media comments and discussions. And finally, the idea that that Pedro is proposing also is here to get citizen science data regarding sea state, position of shoreline. So there are several projects doing this. I'm not sure we can still include it in the project in EOatSEE. It's again an issue of opportunity. If we find that within some of the use cases that we have already an initiative in place, then for sure we can use it. But I don't think that we will have enough time and resources to actually promote this, to create a place where people can take pictures and so we can identify shoreline with some kind of AI algorithm or something. So this is something that I would say it's green here, but it's almost purple. So it's if we get the opportunity, we will do it. Otherwise, I think it's something that will be left as an idea for the roadmap.
Yeah, it was more a comment. I was not suggesting it to do it. It was more because I know there is an initiative from people from Australia called Coast Snap, and is already implemented at a global scale. And they already have automatic algorithms to extract shoreline positions. And I don't know how this could be maybe combined with the shoreline that is retrieved from satellite, and for example improve at some of these locations the temporal resolution. But this is just a comment, not really something to put an effort on. I think it's good to be aware of some ongoing initiatives that might also be contributing to some observations. So it's just for that.
Okay, thanks, Pedro. Anyone has other ideas about citizen science? Maybe we are not aware of what can be done. So let's hear from the audience if anyone has worked with this before, have prior experiences. Okay, so seems the group is a bit shy or even resting a little bit after lunch. So let's try to progress to the next one. This is regarding, of course, coastal works, and that was answered at the opportunity by Marika and Pedro. So, of course, here is where we try to consider the anthropic interventions into these environments and see if we're considering. So basically, yes, that's one of the key advantages of the forest model, because it allows for variations on the beach profile, then you can actually introduce this artificial nourishments or other engineering work, and it's possible. So for sure, in our long-term approach, this will be considered. I would say in the short-term approach, it's very much linked to the tipping point issues. So if we see that some location has a vulnerability to a particular kind of storm, then we might see that some years later, someone actually implemented engineering work and let's say erase or eliminated that vulnerability. So it could be the case also to look in the short term and just compare the two different situations. Again, an opportunity issue. This was not identified at this stage as a task, but we can maybe address this. So any other comments about this? Is quite a common framework if we think about consultancy work, when you have let's say simulations without the engineering work and with the engineering work to evaluate its effects. So this is quite like bread and butter of the consultancy work.
I think I was just commenting on this, Pedro. Just maybe I think this is kind of it follows a number of steps. So first steps by combining these data sets, trying to assess the models, trying to validate and assess how well these tools and solutions improve the existing tools or not, what is missing, everything. And then to put in a stage of applying as a solution for another application, which is coastal protection, is a further step, I would say, in the end. I mean, if you have the model and the tools in the place and they are working as you expect and performing well, to do this kind of analysis is relatively simple. But first, there is a number of steps to consolidate before arriving to that point. So I would say that this type of applications should be considered for sure if a certain condition or result or accuracy or certainty is achieved. So if we are confident of the modelings we have in place, or have an evaluation of the uncertainties, then we could go ahead with this. But I would say there is a step by step, or almost like, not sure if this blocks some of the ideas, but I think it's just to maybe give a bit more of realistic. Also we are doing these things, and we are trying several things from zero, some of them, and data sets and everything, and to do something like this is for me is the next step. But I mean, it's open discussion, of course.
Yeah, I'm sure, like we discussed, it will come up in the Dutch use case for sure for the long-term approach. For the short term, is a bit different. We might address it, but maybe I could also include here, Pedro, another note for the roadmap. So address human intervention in the short term, because I don't think we're doing this, but maybe something that we can put here to remind us a little bit more.
You have a comment also? Sorry, just to interrupt.
Yes.
Okay, so you're sorry.
I saw the one on Q&A. Yeah, so that's this one. I'm actually putting it here already because it's regarding citizen science. So we got this comment from Dr. Melly. I'm sorry, and maybe you could speak a little bit, Mehi, about your experience with this. You're mentioning the group of Earth observations, GEL, but I'm not sure which kind of experience they have specifically related to coastal risks and vulnerability and hazards, of course.
Yes, can you hear me?
Yes, please.
Okay, yeah. So I do not know the scope of their projects, and it would be my guess that they would have a coastal vulnerability citizen science. I just know that there is a large leadership group within the group on Earth observations. You know, they have a name, but there's a community of practice for citizen science, and perhaps I'd be happy to connect you with them, and perhaps they could speak more about their connections with this issue, with citizen science in flooding and coastal resilience. So I'm happy to give you names and connections.
Thank you very much. I think also Moutinho is also quite engaged with GEL, so for sure this is quite interesting. I knew they'd had a citizen science focus group, but indeed we need to check with them if they are addressing this sort of topics. Thanks a lot for the suggestion. Any data we can get is always useful. This project is all about combining data from different sources, so let's put a note on this. So maybe take a look at other stuff here. What else we get? This was quite an interesting question from Damian regarding the validation of flood extent predictions with geological records of coastal flooding. So it has to do a little bit with the timescales that we're discussing in the project. And so even when addressing long-term approach, we are really looking at 20 years, maybe a little bit more, but we cannot go beyond the satellite era. That's for sure. We are trying to connect this with Earth observation, so we cannot go beyond that. So I'm not sure. I'm very naive on this kind of records that we can get in terms of time scales. So I'm not sure if Damian is still here. Maybe we could get more clarification on this, Damian, if you could speak. Yes. I see you have your
Okay, do you hear me?
hand raised. Yes, we can hear you.
Oh,
thanks.
Okay, thank you. So I fully understand that it's not a part of your current investigation, but I wanted to raise this topic as a future goals of such predictions because I see that the geological archive is usually not included in most of the studies, and it contains the information about some extreme events that took place on the coasts that are several thousand years old or more, and they can be useful somehow. And this is important in long-term approach because some, let's say, extreme events occur with frequency of once per 100 years, 500 years. So it's very difficult to predict anything of it. The main problem is that we have no calibration tool to easily combine any kind of instrumental data with geological archives. So this is an important thing. And maybe I will try to provide some more insights or thoughts with some message to you. I was just wondering if you even considered to use some other kind of data to validate the models. But thank you for all the stuff you've presented. This sounds very interesting, and I'm very interested in the project. So thank you.
Okay, thank you very much. I mean, for sure, we're interested. Like I said, it's not exact. The time range is we are kind of limited in this project of looking at things that we can find data on satellite. So we're kind of outside of this time range, but I totally agree. This could be very important, and it has implications to our work also, because if we don't see these events, it doesn't mean that they won't happen in the coming 100 years. So it's something that we for sure at least must include in the literature review. But for sure, we want to include this in the roadmap. I agree that this is important work that could be pointed out here.
Yeah, maybe not for 70,000, like few thousands, but.
Okay, I heard more, but a few thousands.
Okay, but thank you for including this.
Excellent. And also, you said about sending additional information and publications. Anything that you can send us will be greatly appreciated. So I'm not sure we mentioned this, but after this event today, we will follow this with an email. And of course, the main point of contact is through the Air Center. But anything that you send them for sure will come to our hands. So let us know if you have other information, because this seems quite interesting.
Sure, thanks.
Damian, thank you for the feedback. Just to maybe just to ask you, so you could go back in time several hundreds of years or even more. So that means that you could extend some of the data sets we have in terms of impacts or possibly impacts, the identification of at least the occurrence of these really extreme events. What sort of methodological approaches would you suggest for this, or normally you use to do this type of analysis? Would it be sampling like a box cores, or ground penetrating radar, or the combination of both? What type of methodological approach would be necessary?
That's a problem, but mainly there are different sedimentary proxies that are recorded in geological cores, mainly on lacustrine environments, in lagoons, and in coastal wetlands. They are always incomplete, but sometimes it's possible to get at least insights about the frequency or minimum inundation distance from the past. So at least the models could be validated to see if they are not underestimated in the case of worst case scenarios or some extreme situations. But I will try to provide you more details later.
Okay, thank you.
Pedro, may I ask a question or a comment?
Well, you may. I couldn't because I was muted, but please.
sorry. No,
I forgot.
Yeah, risks and vulnerability are inherently linked to human presence. I mean, so every time we discuss risks and vulnerability, of course, we talk about coasts, about dunes and everything, but human settlements, I mean, the human presence in general is very important. Are you planning to include any kind of a socioeconomic data that you can appraise this risk and vulnerability in terms of socioeconomic indicators as well?
That's a very good question, and unfortunately, I don't have the best answer because it's no. The answer is no, because basically, of course, we totally understand there is no risk where there is no people. That the concept, at least for anthropic risk. But of course, this is kind of outside of the scope because we just have so much thing to do in the project. But what we are doing is we are considering land use, land cover in some cases as a vulnerability indicator. but we are not doing economic and socioeconomic analysis to attribute values, which would be, let's say, the necessary work to have a real assessment. What we will do is that we'll some of these use cases have performed such analysis. And then what we can do is to see what is the impact of adding Earth observation data. So this will for sure change the physical setting. And then with this new physical setting, we can try to, let's say, recalculate the risk based in the previous work that they do. This is not something that is that's envisaged. It's not something that we are considering in the project, but it's a possibility to at least have some economic indicator. But it really depends on if this kind of analysis has been provided before, if the data is freely available, because this is another thing. This economic data can be quite sensitive. So in some cases, we have the analysis, but we cannot use it just because of legal issues. So it's something to try to explore. So I'm going to have a purple stick here because socioeconomic analysis for sure is important for risk assessment, but it's not something that we are addressing directly in the project.
Maybe it could be included in the roadmap like a potential layer to be explored by third parties after the delivery of the project.
You mean a layer of
the
economic information?
Yes, exactly. You know, maybe I mean the final, let's say, architecture of the solutions would have to allow, to add some layers of interpretation of the data, including socioeconomic data.
Yes. For sure, yeah, that's something that we need to try to include. It's unfortunately it's quite hard in some cases because of these legal issues with data, sensitive issues with the data.
Yeah.
But yeah, you're totally right. Risk assessment is not complete until you have that. So at least it deserves a purple stick here for sure. So let's try to come back to this one. So I think this was also another topic quite interesting about these plants, algae, mangroves, seagrasses. So we had a lot of answers on this because it was quite an interesting topic. So within the proposed approach now, at least for short term and long term, this is not really possible. We are not adding something that is not there already. Of course, if there's one of these downscaled high resolution models already has some sort of different roughness of sea bottom because of plants, this is already implemented. Then, of course, we will take advantage of this, but we cannot add new information from EO, at least not in the scope of this project. So what we can do is, again, whenever this is implemented, we can test what the effects of adding EO data has in the model, in both scenarios, with the algae, with the seagrass, or without it. And we can see if the effects are different. So this is one possibility. I think it can probably be executed within the Adriatic use case where they already have some of this information, but it's still to be evaluated. Again, it's not vegetation per se, but it's also living animals, in this case, coral reefs in Majuro. So it's something that, for instance, we can try to address with bathymetry. It's quite hard because even if you take bathymetry from satellite in, let's say, with a difference for 5 years, coral growth is quite slow. and I'm not sure that we can detect any changes regarding this, but of course it would be interesting. That's the only, let's say, detection tool that we have for this topic. Like I said, the North Adriatic use case might open some doors for evaluating this. But then I also included some of the suggestions from Ivan, from Pedro, to actually provide detection of seagrass, actually provide modeling tools that consider this nature-based solutions, even with this reduced complexity approach. So it's challenges for the future, I would say. This one with seagrass detection it's quite well advanced. There's a lot of activity now in the Mediterranean doing this. So we might be able to actually explore, because that's another thing, and we have 2 years ahead of us. So we might have new data sets coming, new information coming, and then we can explore. So for instance, if we got a lot of new data, new maps of seagrass, I don't know, monthly maps, annual maps in available in Copernicus or any other source, then we might be able to use it. I think that's one of the potential cases is the one in the Mediterranean. Not sure if we might get anything else from other use cases. So that concludes the risk and vulnerability part. Please, I'm sometimes I talk too much, so please interrupt me and then raise your hand and put comments. I see we have another. Yeah, no, it's just an answer from Mehi. So. Okay, so we can move to this next one on process understanding. A lot of different interesting issues here also. It seems like we're going to go a little bit over the time, so we probably have to delay a little bit or break. It was planned for 3, but probably let's see how it goes. But it's okay. This is the most important session of all, where we try to really raise these issues. So this is a very specific question from Francisco. So regarding the Lisbon use case, I guess unless Francisco has something to answer regarding this, there's not much we can discuss. So yes, actually he has provided an answer, and it was just a little bit misplaced. So I'm not sure, Pedro, you want to comment on this, or it's we already have this model implemented, I think, for this downscaled in Carcavelos.
I mean, it's definitely I definitely should have a conversation with Francisco. I think he already gave several comments here that we should talk about, considering they have worked for a longer time period in this region of interest. So I think all these aspects are very specific of the local use case. Something that we should be able to evolve if we talk. Yeah.
Yes, indeed. So for sure, we'll collaborate with LANAC and everyone else which is interested. As you know, Francisco probably knows this, but a lot of the team that is currently working in Plus Atlantic with this use case is the team that was previously in Maritech. So the actual developers from Wahid models. So we are quite well equipped here, and I think it's quite fortunate because Tagus Estuary is definitely very interesting area to explore, and very exposed and a lot of risks. Very active. So let's go for it. So another comment here from Professor Jimenez again, and this is about the nomenclature. So yeah, that's something that we need to understand. I'm not sure, maybe Professor Jimenez, if he's still here, could raise this again by saying what he thinks about the name cascading. I'm not sure, Pedro, have you, we've seen this before in the literature, so it's not the first time I see this being called the process cascading. So
I think we definitely will need to look at it. That's something I would take out from this comment is we definitely should look at it and assess which name or which how we should address this process. So I think that's the main outcome of this exchange.
assess it in literature, basically.
Yeah.
But in this is one of the key elements of innovation in EOatSEE. So just to remember here, this is where we try to consider the morphology, the coastal morphology response to extreme events, and then simulate the new extreme event with a new morphological setting. So that's, I think, one of the strong points of the project. That's what we can really provide in terms of innovation by evaluating this tool. It's something that's going to be done in all use cases. So we'll have a lot of, let's say, validation for this. And
it's interesting, but because I'm now remembering, I think this wording is coming from the call, actually. I think this wording was in the call.
Yeah,
so I
that's
think
it.
we were trying to use similar. So it's definitely a wording subject, but it sounds. I think it somehow relates with the process
familiar.
Itself. Yeah, of course, maybe it's not correct scientifically correct, but it reminds the process. But of course, it's better to have a clear scientific justification than just a nice name that makes us visualize things. So I think we should definitely consider this comment.
Yeah, there's. I'm trying to remember. There's a word in English for this recurrence of something that's recurrent all the time, but it's escaping my mind right now. But for sure, we will review this and then check where this came from and try to come up with a better, more suited name definition. Okay, we have another question, but I'll just go over. Well, we can go over the question already because it then gets more and more interactive, of course. So I will put it here because it's quite interesting. Also, it's about impact and dissemination. So, of course, this brings a very important topic, which is the solutions. We don't want to just be talking about these things. We want to actually provide the impact in society. So indeed, there's a whole work package in the project dedicated to transferring these results to society. So at first, like I said, the first basic baseline approach is just to expose all the results, all the analysis into a gel portal. So in a very easy, user-friendly tool that anyone can access, see the data in a map, compare different layers. This is the baseline, let's say. But of course, it comes together with indeed capacity building, documentation, everything. It will follow this. It will, within the project, this will be provided for the early adopters and eventually other stakeholders, but only within these use cases that the project already have. So this is the, let's say, the scope limitation of the project. On the other hand, for sure, as this is a community effort, the consortium and all partners are quite open to promote capacity building and to promote these results and showcase them to different end users that are interested in these tools, which of course can then lead to new initiatives, new projects, or even new additional work to be done outside of EOatSEE. But yes, my answer for this is basically yes. We are going to provide capacity building, and we are going to share these results. The limitation is that we have a set of use cases in the project, and that's what we have planned for. But we are quite open to collaborate and to communicate with other interest and the users also. So in Earth observation, end users are quite valuable. So that's me saying outside of this project. From my experience, I've been working for a couple of years in this right now in the industry, and we lack enough users. So anytime someone is willing to experiment, to dedicate some time, to provide some feedback, we're very happy to do it. We're very happy to interact. So don't be shy and let us know. Please let us know. This came from Paulo. So thanks, Paulo, for this. I will actually put here your name, so just we don't forget, and we will come back to you. Oh, I've probably miswrote something here. Let's make sure I got your name right. Yeah, that's it. Okay. There's another comment here which refers to that previous topic, so I will go very quickly about the effects of vegetations and in this case the question was about kelp, was putting as example kelp beds. Again, it's the same for any of this vegetation. It would of course affect the roughness, it would offer the protection, but it's not included unless it's already included in the original numerical modeling implementation. So again, planning for future work, it's quite interesting that people are working on this. There's already a lot of different projects and initiatives looking at detecting this, but I'm not sure they are actually connecting this with modeling of coastal risks. I'm quite doubt it. So for sure, there's a open avenue here for research and collaboration. So we're definitely going to be looking at this.
Also different, there are different processes just in this box. You have kelp, seagrass, mangroves, they're all different interactions. So mangroves, you have sediment deposition, interactions with currents, sediment balance, a lot of process going on. But for the kelps, I think they are quite different processes because they are all submerged all the time, I think. So I put this in the same, I would say that this is in the same box of this adaptation measures, building with nature, or some kind of suggestions to look at this type of building with nature approaches. I think we got quite a few that can be grouped already
yeah, of course. Yeah. Once we start building this roadmap, for sure we'll consolidate. It's quite a lot of work to do because, as you said, these are very different things. We're talking about the submerged vegetation, but also immersed vegetation on the dune. So there's a lot of different things here. But just I think that connecting these two let's say research communities, the ones that are trying to detect this from space, and the ones that are trying to assess the risk of this with the modeling tools. Would be quite interesting. This connection would be quite interesting to make. So maybe seagrass is a good starting point. So let's see. We the only one that we suggested that we can do something within the EOatSEE is seagrass in the Adriatic Sea. So maybe that's a good starting point for getting to this topic. This is also something that was interesting regarding the force model. Again, it's one of the main solutions that we are experimenting with in the project. Is probably the most innovative tool that we are using in terms of, at least in terms of modeling. So quite powerful, especially combined with this EO datasets that are available globally for a long time series. We can do a lot of things. That's exactly what we want to do in the project. So after this, will it be converted in a practical solution? So I have one comment that I made at the time, and it's not included here, but basically what we're doing is to implement this in a cloud infrastructure in a very, let's say, professional way, in a way that is the algorithms would be available to be deployed as applications afterwards. So to be readily scalable or easy to use in other locations. So I think this is already a good part of the work, because if we are able to, let's say, get this model within the algorithm, already have a lot of data that can be used with it, and this data has global coverage, and then we produce all the documentation for this setup also. We kind of have already start to finish tool for anyone that wants to use it. So it's almost out there, but of course it's not like you can download from some website and start using it. At least that's not what we expect to provide in this project. Let's see how it gets. Pedro has a previous experience with the CASI tool, which is now totally available, totally open for free, and can be run anywhere in the world. So it's something that can be done. In that case, it was hosted in Google Earth Engine. So we're not using this tool in this project. We're using Deimos proprietary platforms. But the idea of Earth Observatory Exploitation Platform, for anyone that has been following that topic, is that they are compatible. They are fair, though, so they should be easy to transfer for different infrastructures. So we are working in that direction. And making sure that once we got to the end of the project, anyone can still use these tools. How much effort it will be needed to implement this, it's still not so clear. It depends on how this project goes and how the actual implementation finishes. So as an example, I will provide an example, very practical. When we build a gel portal, we can use this gel portal to put their data collections. So just expose data sets, which is what we plan to do here. But we could conceivably also expose processing services. So we could have applications where the user select a study area, provide some input parameters, ask for run that application, and a couple of minutes later, or maybe depending on the algorithm, some good hours later, he gets the results. In the same gel portal, he can visualize the results and download the results. So this is conceivable. I'm not promising that we are going to do it, but it's a possibility on the horizon here, at least for some of the applications, not all of them, but some of them. So that's my very complete answer. But also we have here the purple sticker, just to mention that we cannot forget this. Even if we don't provide, we need to see how, at least explain how it should be done in the future. I have one comment here about the scenarios, but I knew oh no, this is copied. It's already here. So regarding IPCC scenarios, no, this is not here. So we got some confusions with the stickers here. But basically, what we have in the project is one of the partners, the Deltares, has already produced several future projections for IPCC. So their results were published in the IPCC, as Tony explained. And what we're doing now is adding these new capabilities that we have and try to understand if these results, how they compare to their previous analysis, and criticize these results, of course. So yes, the answer is yes, we are definitely running it for at least 2 IPCC scenarios and evaluating these results against the previous work. So again, I'm talking a bit too much, so please interrupt me and propose new topics if you feel that something's missing here. So Ibrahima has mentioned this vulnerability indexes. So there are different ways of building vulnerability indexes, and the one that we are proposing here is really a flood extension map where we simulate some extreme events, and we have this flood extension map. Of course, the flood extension maps will be, let's say, coupled with the offshore sea level. So, of course, we need to create different scenarios and then see how they affect the flooding. The other index, it's quite interesting and innovative, is the one that Pedro mentioned that combines information for erosion and flooding. So this one, it's really, again, the one of the key innovative aspects of the project. After running this reduced complexity models for 20 years, we will be able to give a score to these areas in terms of vulnerability, at the same time considering erosion and inundation. So I think indeed vulnerability indexes are one of the key products of the project, and we are quite excited to see what impact they will have for these early adopters. So how they will evaluate this against their local experience, which of course is quite valuable. So I guess we comment on that one already earlier. And this comment from Mayalen also related to the transfer of these results to society. So her suggestion is that we implement the approach of the cascading effect. We saw that this got good reactions from the audience. That we are approaching this recurrence effects, let's say, the combination of different storms in the long term. We are definitely looking at this. So her suggestion is that we implement this also into operational forecasts, which of course, these are the tools that can actually provide impact and avoid loss of lights, loss of properties. So it's not an easy task because these reduced complexity models, they will be looking at the long term and not so much at the short term. So we need to make a framework shift. So once we understand how this effect happens and how important it is in the different locations of the use cases, then we need to probably implement some changes in the operational forecast model that we have for the location. So how to do it it is still very open, I would say. For sure, that's something that we want to do. We will provide some updated operational forecast models. That's one of the tasks that we have in this idea of transferring results for society. So to transfer this particular aspect, the aspect of recurrent events, it's a problem because of the time scale, but it's something that we can try to address with a framework shift, like I said. So basically, we need to make sure that each time that this model is running and is providing forecasts, the initial conditions are representative of the already effects of prior storms. So how to do it, it is still open for discussion. I think we might have different communications between maybe the long-term and the short-term modeling tools, or even with AO data, other satellite data that we can include here. But it's a very good suggestion, at least I would say. At this stage, it's not clear for me how we can do it, but it's for sure something to be discussed. And for sure within the scope of the project, this is something that we need to look. So I'm not sure if we could add any other comments. I will actually put another for the roadmap, because I think this is just important.
And Pedro, maybe I see there are no more comments. We are already 17 minutes past, the coffee break hour. Maybe we could stop for 5-10 minutes and then come back to the next part. What do you think?
Yes, Moutinho, for sure. I'm just making sure that we didn't left anyone behind. Any other behind, but I'm almost sure that we covered all of them. Yeah. Well, covered all of them. There was another request for contact. This is also something that was quite interesting from today's meeting. We got several requests for keeping in touch, just make sure that we inform the people when we look for collaborating on very specific topics. So thanks for that. It was quite interesting, and for sure you can be sure that you'll be contacted in the coming weeks or months, so that we can keep this collaboration. So yes, indeed, we can now close this part. So this was quite interesting and quite valuable. We got a lot of feedback, a lot of interesting insights from the audience. And also, I think was a good opportunity to showcase in detail, in depth, what we're doing in the project, what we plan to do in the project, and some of the possibilities, because we're just starting. So there are still open possibilities. And the last session of the day, we want to explore a little bit what's going to happen after the project. So that would be until, let's say, we would have another hour for that. So I guess we can have it from 3:30. So 3:45. Yeah, I guess we can have it again. We can meet again at 3:45 or 3:40. What do you think, Moutinho? I think because now I've broke the agenda because already.
Maybe 20 minutes will be too much. Maybe 15 minutes will be okay. Like 3:35 is 3:20 now. We give 15 minutes around. Okay. 3:30, 3:35, we'll be back.
Okay, so we reconvene at 3:35. Same link. One last just comment. If anyone was not here in the morning, this is being recorded, is available on the Air Center YouTube channel. But also, if you want to provide additional comments, additional questions, criticism, or just say that we're not doing a good work, just let us know. We are very keen to interact with everyone. So Air Center is the main point of contact. If you're not able to comment here in the platform, you can always write afterwards to Air Center and mention EOatSEE, and we for sure will be receiving the contacts. So yes, let's close a little bit and we reconvene here at 3:35. Thank you.
Alô? Oi, tá correndo bem pra caramba, né, cara? Pô. Essa parte agora eu sei. Pedro, maybe we could start, no?
Yes, I think we should. I'm not sure if you're talking with me or the other Pedro.
Yeah, both Pedro.
Saving.
Yeah.
It's
I try
easy.
to compensate Pedro to talking so much of
it's easy to get an answer from Pedro in this project. So there's always someone hearing. So yes, thanks all for coming back. So let's go for the third and last part of, well, almost last. We are still gonna have some closing remarks, but very short. So the last technical part of the workshop today, where we're going to review the scientific roadmap. So some of the ideas that we cannot fit in EOatSEE, but we can still have a first glance at them and try to address them in coming projects. So I'm going to share again my board. But what I did now is I concentrated all these requests in the purple stickers, all these ideas that came, and I'm very thankful for the discussions and the ideas that we got from this audience. I think that indeed, this is already a roadmap just with what we have here. It's just as long as we develop all of this, is going to be quite important. I think this is interesting. I think we are living in a very interesting moment in ocean sciences. Of course, we are going through the ocean decade. We just had the event in Lisbon a couple of months ago to officially inaugurate the decade. But even before that, as you probably are already engaged in several different activities from the decade, I think also it's important to understand. We also one of the main trending topics and one of the main targets for Europe right now is to develop the digital twins and digital twins of the Earth, and of course the largest initiative in that sense is the Destination Earth, being conducted by ESA together with SMWF and I'm sorry, I lost the third partner. Just missed the name from my head. So, but no worries. You all are familiar with Destination Earth. The thing that I want to mention about this here is that the first two calls that they have for digital twins are for ocean health and climate science, so climate risks. And basically, that's what we're doing here. We're really looking at climate risks. This is a very important topic and becomes even more important when we are already living in a time where we have climate refugees already fleeing from isolated island countries. We have terrible tragedies going on all the time. We just had now in Bangladesh, Pakistan. But anyway, we still have these events happening in Europe, and they will just become stronger and more frequent. I think that's something that we already agree on this. We don't have to discuss anymore. I think everyone is now, the scientific community is quite joined in this, seeing that this is going to be more and more important to address these scientific issues. So to offer some options for society to face these challenges. So this is excellent. We already have covered a lot of ground from the project scope for what we want to do in the project, and what you have in the screen right now. It's a lot of different suggestions that we don't think we will be able to fully covered in the project. So maybe some of them we can partially cover, but not fully. So the first one that I want to comment quite quickly is about the transformation of this EOatSEE products in practical solutions, even for consultancy work, but also, of course, for academic work and this even public institutions or whoever wants to use these tools. So on that, I must highlight that from the start, we are planning to integrate these solutions as much as possible into this Earth observation exploitation platform, which is something that ESA has been fostering this development of such exploitation platforms in the last couple of years. And the idea here is really to ensure compatibility. So if you have your own platform, it should be compatible with the tools and solutions that we have integrated in our platform, in our side. So that's the idea, that we follow standards, and these standards are defined by the group of Earth observation, and we follow them very closely, very strictly, to make sure that these applications are reusable in other platform, other settings. So not only the data will be provided for sure, like I said several times, we are producing data also outside of the use cases. In some particular science cases, we want to produce data, for instance, in some areas of interest that are outside of our specific use cases, but are overlapping with the works of, for instance, ALMAR 2021. So this recent work that estimates coastal vulnerability, we want to try to provide data in the exact same transacts so that we can compare. So in some cases, we will have some data outside of the use cases. But then, of course, if you want to produce for your own location, for your own setting, then, of course, you need to run the solution yourself. And we want to make sure that this is possible after the project is finished. How it's going to be done, it's still to be defined. I think we have almost 2 years ahead of us, so a lot of things can happen. But in some way, we will provide even maybe we can go all the way to have a geoportal that can do it all automatically for you. Maybe we can have a code in GitHub that anyone can reuse. Let's see. It's still up for decision, but we are definitely trying to go the further we can in terms of implementation, in terms of easy of use, to make this easy for anyone else to use. So that's our targets, and for sure it's gonna be. Still, I don't have the precise answers. It's gonna be something that we're working forward.
Yeah, if Pedro, if I may build on your comment, I mean, you said about not only consultancy, commercial consultants, but also academic. I hope Geraldo is available. I'd like to hear his comment on the possibility of using, I mean, these solutions in terms of academic work. He was connected, but I guess he was just connected, but I guess he dropped the connection. He told me that the connection wasn't so good. So we wait a while until he comes back.
Okay.
And then we will include him in this discussion, because he could help us to, let's say, I mean, give another perspective on how this project could be transformed in solutions for academic work as well.
For sure. We're very much interested in which are the most convenient way to share the impact of this project. So for sure, that's our intention. That's really, we are much aligned in that we want to cause as much impact as we can. So collaboration is the key for that. So I'll go over some of the others quite quickly. That one was very dear to me, that we need to share this. We need. I just don't want to be another project that produce a lot of interesting things and then don't have impact in society. We really, it's time. We cannot wait anymore. We really must change things on the ground. So that one is maybe the one that's more dear to my heart. But now I'm going to go through some of the others. As we saw this before, I'm going a bit quick. So please interrupt me if you see something that you're interested in and you want to comment a little more. And again, these are some of the topics. If you are inspired to get other topics that we also should address in future work, we're really, really interested in hearing from you. So we have this idea, actually, Moutinho mentioned that we, of course, need to integrate this socioeconomic analysis, socioeconomic information to actually provide a risk assessment. So probably what we can do here, right from the start, is to make sure our tools are ready for it. So make sure that we offer the necessary data and the necessary tool, that if someone has this socioeconomic information, it can just plug to our data and everything will show neat. Again, this is a bit about standards, a bit about trying to make sure that these files are reusable. So it's making sure that we're compliant with the fair approach. So in terms of data sharing.
Good.
Yes.
Just commenting on your first box. Since we have early user adopters, and we talk about this in the past, of having like or a short meeting or something, or a workshop or something that we could get also requirements. And since we are applying somehow similar tools to different different setups, possible environments, different problems, more or less different problems, not so different. But it could be a way also to somehow identify the market requirements, because they are the ones, if this is as an intention of going to more consultancy or to apply the solutions, they are the ones who are going to give the requirements. They are the ones who have the needs and the pains. So maybe this could also be consolidated with some information from early user adopters.
For sure. They are the early adopters are, or let's say, our first step into that direction. But this is really aiming to go over a couple of more steps. So, but you're totally right. The work will begin. Actually, the work is beginning today, because we are hearing already a lot of experts and scientists and also early adopters. We just got the environmental ministry of Dominican Republic on the audience, so we have a very interesting audience providing insights. So but again, it will for sure be deepened within the project by the conversations and interaction with early adopters. But what I'm inviting here is actually that this community can also provide these requirements through the duration of the project. So if you start a new project and you think that it fits here, okay, we're probably not going to be be able to accommodate additional work within the project to provide you specific tools, but we can for sure share what we are doing and make sure that we try to be as ready as we can to include other requirements. So to include comply with other requirements that you have. So anyone from this community is really welcome to provide requirements along the project. We are really keen to understand what's important in order to make sure this provokes the most possible impact in society, which the end goal anyway. So excellent. But yeah, for sure, the early adopter are a key aspect of this. So like I said, going a bit on the scientific topics again. So that's something that we discussed, the possibility to include these effects from storm recurrence into these operational, short-term, very high resolution numerical models. It is a big challenge. It is a big challenge because currently we don't have an automatic model that can make sure that it's doing this. So basically, what it's a bit on the sensitivity of the operator, of the modeler, that can, of course, always stop and create new initial conditions and see that the model is deviating too much from realities, from validation data. You can use a bit of a simulation here. Of course, it's also a strategy to make sure you're doing that. But it's a bit different from what we explain when talking about long-term evolution. We really see that there are these tipping points, these points where the state of the beach totally changes, the state of the environment changes, and they really affect it in a way that probably with these non-linear relationships, it's not really reflected in the models. So a challenge, very complex one that we should try to address in the future. This one also quite interesting to maybe the key word here is preconditioning. So if you have a lot of flooding inland already, and then you have a coastal flooding, this is really, of course, as we all know, this is what usually happens in the worst disasters. So it's not by coincidence this is here. Of course, it's one more. It's a lot more complex when we are trying to model also inland and even underground waters. So it's really becomes quite complex. But the reality is that the tools are there. We have some tools available. If we can be ambitious enough to combine these tools, we might just be able to do this. So again, a bit out of the scope, but it's for sure something that we need to look for the future. Well, that is about in situ data. So that's where, okay, I'm not offering anything anymore. Now I'm asking. So that's the different one. At the same time, we want to collaborate with everyone. We want to provide this data sets. For instance, we just a very quick example. We did a very extensive review of available EO datasets, the state of the art, things that were released like 2 months ago, things that are quite new. For instance, we have now a dataset about land movement, very precise, coming from INSAR interferometry, covering all the European territory, and it's very precise and has just been released. So we have these tools that have just been released, and we have an inventory of those tools. So anyone that is interested, we can share these tables, we can share these lists. I think this is already something that we can do. Even at this stage, of course, later stages in the project, we can actually share the results and the tools and the algorithms. So that's quite interesting. But on the other hand, if anyone is working in the areas of study where we are going to have this scientific work being done, and especially if you are addressing extreme events with in situ measurements, well, then it becomes quite valuable for us. So we are really interested in collaborating with any future projects or initiatives, or even current ones that will try to address extreme events with in situ data. Even in the future, I think this is important because outside of the horizon of the project, we also, for sure, all the institutions of the consortium will keep on working on these topics. We'll keep on working on these particular locations. So we are still interested, quite interesting to work with you and maybe conceive some projects where we can combine the capabilities of in situ campaigns with Earth observation, with numerical modeling all together, AI, whatever else we can do, citizen science. This is really the goal here, to combine the information we can get from all the sources we can get. Here's a very hard one. If I was to grade these challenges, this would probably get one of the highest grades. To have a digital elevation model precise enough and feasible, but still precise enough to simulate wave run-up with good confidence. It's a challenge. It's a challenge, but as we discussed before, this can become quite important in some environments. Even just the run-up, not the full setup, but just the run-up can also be important in some very specific locations. So for the future, again, one idea that Pedro raised here was to use coastal video imagery extract some of this information. It's something that, of course, we have a lot of work ongoing, people measuring waves, people measuring shoreline position, and different things with cameras in the beach. There are a lot of synergistic opportunities here. So again, looking to future projects, we would be keen to participate and to collaborate with anyone that's looking at those topics. I get okay, let's go for what else we have here. So engineering human intervention is short term. This is the wording here is very bad, but I will have to review it for sure. It's just a quick notes. But basically, we saw that some of our approaches for long term can accommodate interventions, engineering interventions. Not the same for the short term, but basically the short term you have to run it again. And simulate different scenarios, which is the usual approach. I'm not sure how much we can help. Probably if we get a better temporal resolution on Earth observation data, for sure this could be improved in the short term. We are still not there, but again, it's a goal for the future.
Sorry, but is this the kind of, for example, beach nourishment?
Yes, that's the idea. Because as I said, with the long term, okay, we can accommodate it in the force model. With the short term, basically what you can do is you can simulate the scenario with the intervention, without the intervention, with different intervention. And I'm sure that a lot of the people in the audience, that's their day-to-day work, because that's what consultancy firms do a lot, simulate these scenarios. But I'm thinking here how they can Earth observation contributes to improve that. So this is a bit harder because of the limitations of the temporal resolution. So it's a bit harder, but again, it's a target. We all know that satellite sensors are increasing their resolution both in time and space. We have new sensors being sent to space every month. So in the future, probably we will be in a better position to address this. And that's also part of our mission here, to define objectives, not only for downstream, for the applications, the algorithms, but also for the upstream, what kind of sensors we need, what kind of satellites we need, what kind of, let's say, observations we need to improve this. It's quite interesting. I think when you mentioned the cameras, maybe there's a connection here. Cameras might be a way to have this updated in real time. So imagine that a work of an engineer is occurring and the beach nourishment is occurring. You can have this camera getting shoreline positions all the time and actually communicating with the model. So conceivably, you could build a tool like this. It's a bit challenging, but I think it's something to look. We got this one from the geological records information. Again, quite interesting. I think it's when working with historical trends and future projections, this becomes really relevant. Of course, from geological records, you can get information on extreme events, but also on the sea level position. So, and sometimes even some environmental conditions you can get also from geological records. So it's really interesting that you build this history and base your insights, your conclusions on the previous history of each location. So this is quite an interesting way of looking at the topic. And I think we need to look at this, at least for the use cases we have in the project, but also to point out that this could be a direction for research, at least in the case of a very strong event with a long recurrence period, like 1,000 years. We need to look at this. And for sure, and I must say, this is way outside of the conversations that we had so far in the project. So We have for sure not even conceived this idea. So it's just raising it was quite interesting. And now we must investigate it a little bit further to see what are the time scales we're talking about. Maybe there's something here that we can actually integrate. So we need to go a little bit deeper on this before just putting in the roadmap. For sure it's in the roadmap, but I think there's some possibility also that we need to check. I'm almost there. So this one is also one that took a lot of discussions on our side about the seagrass, vegetation, mangrove, and nature-based solutions as a whole. How they can be incorporated, in this time incorporated in the long-term approach, in the reduced models, in reduced complexity models. So these models doesn't account for bottom roughness, I think. So it's quite more simplified than that. But maybe this is something that we can start looking. And again, this one to connect to the detection of I have here seagrass, but of course also the estimation, the ecosystem assessment applications that are doing this for seagrass, mangrove, and different kinds of vegetation. This can all be connected into these models. So I think this is also something to explore with attention in the future. And address the potential contributions from citizen science. So again, quite an interesting aspect that we are currently not exploring in the project. We're going to take a look, at least connect with a group of Earth observations to understand if they are already producing some work in terms of risk and some coastal hazards and risks, vulnerability. I think I can think of myself of some work that I have seen about this already. So like Pedro mentioned, that there's some work in Australia being done about this. So we need to understand how we can actually integrate this data. There are, of course, issues about the reliability, about the quality of the data. And this is a big discussion when talking about citizen science. But also then there are these more, let's say, quick wins to try to get at least this local knowledge from tipping points. We could use some social science methodology to collect this knowledge. And of course, this one also, it's a lot about, let's say, digital marketing almost, to understand how to identify this information in social media in an automatized way, because no one wants to go through 1,000 tweets, and everyone would be very depressed if do that. So I'm sure we need some kind of automatic approach, and I'm sure it's available. It's just a matter of understanding how this works. Again, falling a little bit outside of the scope of EOatSEE, so probably going to be left for future work. That's actually all I had from the roadmap. I got a comment.
Yeah, Pedro, if I may, one important thing that summarizes a little bit what was said related to the scientific roadmap is that we need to embed EOatSEE solutions on a larger context, linking up with existing initiatives, existing projects, planning activities. So maybe our scientific roadmap will need a kind of initial mapping of the existing, initiatives, projects, so we could start connecting with them in the future, at least prepare for these connections. What do you think about this? In terms of general, we discuss a lot of some of these aspects here as well.
Yes, interesting, because we just got a comment from an initiative that's also related to this, and I'm getting that information also. But yeah, for sure, José, this is crucial. We don't want to reinvent the wheel. We don't want to do something just by ourselves. It is a community effort. So two things, but first is trying to systematize this information. So that's something that we need to start doing quite quickly. I would say we are even a bit late for this right now, but during the discussions that we had in this scientific requirements definition phase, we already raised, of course, even the partners here are engaged in several other initiatives. So we already raised a list of initiatives, but for sure, we know there's a lot of things going on. As we are funded by ESA, we somehow got a bit locked within Europe. So we sometimes don't see so much what's happening in the rest of the world. And we are aware there's a lot of very good work being done everywhere. So for sure, we need to do this. I count a bit on you to help us with this, but also I count that we will. This is today. I think it was really a milestone in terms of communication. We really were able to engage with a very large community. We had a lot of attendees across the day. We are still with a very good group even at this time. So the thing is to keep this network active now. So of course we need to follow up this event today with emails, but I pledge that at least most of you, or if not all of you, sign up for the newsletter, the EOatSEE newsletter. We will offer you this possibility. They won't be long. They will be short updates about what we're doing, making sure that just you keep on hearing from us, so you don't forget us. And whenever you're working with something that's okay, this is related to that work, you can send us an email, send us a hello, and we'll try to connect. And really the word here is synergy, is to provoke impact by taking up all the synergy that we can.
Yeah, maybe, I mean, Fabio from Lance, maybe he would like to say something about how to collaborate. I will promote you to panelist, Fabio. I mean, Fabio was in a car and now he found a nice place to stop and talk with us. I hope he can connect with us now. So we could explore a very practical way of, let's say, engaging with other organizations.
Yeah. Anyway, Moutinho, we also got a comment from Antonio Geraldo, which is also from Lance. So he's suggesting a couple of ways that we can collaborate through training, through academic courses. But indeed, we are very open to collaborate. So basically, I've already said that at this stage, we still don't have that many results, but nevertheless, we already have a review of the state of the art in terms of the best possible data sets that are available for different variables, different parameters related to coastal risks and hazards. So that's already a first result that we could share. I think this is very updated. It's not something that was done years ago. It's really, really updated. We're also looking for things that are still upcoming, that are not released yet, but are some data sets that we know that will come during the project. So in terms of data sets, we're really, really well informed, let's say, and we're well connected with the European Earth observation community. So that's the first point that we could collaborate, but we are keen to collaborate in different aspects. Of course, in terms of capacity building, we could developing something together, and as long as we get the tools. It will take some time still, because we only will be able to share the results and share actual data sets and solutions within the second year of the project. But at this stage, I would say the best, in a later stage, for sure, we can share tools, we can share training, we can share solutions. At this stage, the most important thing for us are the requirements. So if you have scientific questions which you didn't see covered today, that's the main thing that we need right now to get this updated requirements. What are your scientific questions that we are not covering here or that is totally outside? So those are some of the collaborations, immediate collaborations that are possible. Is right away we can discuss, point out to papers, okay, we did that other, but we're missing this data sets. This we can do already. We can work with the data sets and work with the requirements and try to comply with these requirements in the solutions that we'll be developing for the next 2 years. So I think the collaboration starts there. But of course, we are very keen and very open. This is really a community effort. We want to make it a community effort. I also think that this is a kind of a precursor project. You saw we don't have a global coverage. We are looking at particular use cases. We are looking at particular topics. But as you can see in the screen right now, we have a lot of different challenges that we can still include in future projects. So I think that's another thing, that this is also a place to discuss future projects, future collaborations, more practical, and look at the opportunities of funding. And this is all interesting for us. I think we have built quite an interesting group here, which I showed in my very first presentation this morning. With one side, we have an interesting numerical modeling scientific community with Deltares and CMCC, and of course, plus Atlantic. So 3 of the leading European modeling groups. And on the other side, we have Demos and Telespacio and CLS, and also again, Planet Atlantic as service providers, are providers of Earth observation data. Again, kind of the state of the art that we have in Europe. So it's a very strong group, which can be the base for future collaboration.
Yeah. Pedro, Fabio is back.
Yeah,
Fabio,
I see him.
Do you want to say something? Do you want to say something, Fabio, regarding collaboration?
Yeah. Thank you, Moutinho, and I appreciate the invitation to participate in this meeting. I'm Fabio Hochleitner, and I'm a meteorologist and a coordinator of the Earth Observation Group at the Laboratory of Computational Methods in Engineering at the Federal University of Rio de Janeiro. We have a few facilities and a satellite data acquisition and observation system aimed at applications in the environmental area and coastal region of Brazil. One of our projects is Bahia Digital. The Bahia Digital is a project for Guanabara Bay. It's a pilot project for Guanabara Bay. And this project has a main goal, the development and the implementation of an operational digital platform for the provision of environmental, social, and economic information in the around of Guanabara Bay region. The diagnostic and the prognostic information generated, it comes from different sources, such as historical databases, in situ and remote data acquisition platforms, and also numerical computational methods too. In addition to the dissemination of this information, the digital platforms also involves extension, technical, and academic training activities in different research areas. Such activities allow the continuous operation, development, optimization of the platform, involving professionals, students from different educational levels, for instance. Also, the digital platform, the Guanabara Digital Bay platform, it has a public available data, allowing both the visualization, acquisition of relevant information for the different segments of society that use the region of Guanabara Bay and its surrounds. This project is physically based here at LUS. So I would like information about the possibilities of integration with EOatSEE, as well as the possibility of joint development to use the data generated to validate methodologies, for example, the South Atlantic. We are open for collaboration or joint development. So that's why what I would like to talk, to contribute in this meeting.
Excellent, Fabio. This is quite valuable. So for sure, we'll make sure to connect with you and make sure that you follow the results. Like I said, we are just starting. We might maybe at some stage we could have a conversation about the requirements, about what's missing, what you feel that's not so good in terms of satellite data, what are the let's say the weak points of the models, or are you also interested in long-term modeling, not only in the short term? It's a similar setup as we have in our use cases, where we already have this modeling service chain implemented, in some cases also simulating Earth observation data. So it's quite interesting when we have this setup and we can test things there. So I think as a first step, we might have a contact about requirements at some stage, so we can try to set up a meeting for that. And a bit down the road, a little bit further down the road in the project, we start generating results. We make sure to communicate that to your group, and then if your students, your group want to experiment with some of these tools, with some of these ideas, we'll for sure be able to happy to provide any support, any guidance that is needed in Portuguese.
Okay. Thank you very much.
So thanks a lot, Fabio. We'll be in touch for sure.
Yeah,
okay.
Pedro, we have to acknowledge the presence of Carlos Rodrigues from the Ministry of Higher Education, Science and Technology. I mean, as we know, the Dominican Republic has been under pressure because of the Hurricane Fiona. So it's very interesting to have representatives from Dominican Republic in this meeting. And also we have a question from WAC, Santiago from Mexico.
Yes, so I saw that. So it's a different suggestion here from coming from Mexico, to use high resolution satellite altimetry to obtain a bit more information on coastal plains. So he's suggesting to use high resolution satellite altimetry on land. So trying to improve the digital elevation model. At least I understand that this is probably a long track. I have to say this is a new topic for me. So maybe, I'm not sure Olivia is still connected, or someone from altimetry community could maybe provide an answer regarding Sentinel-6 over land.
Yes, I can. Hi, it's Claire speaking.
Thanks, Claire.
I'm back. Yeah.
Thanks, Claire.
So what we can say about that is that, yes, we can use satellite altimetry below the track to monitor the water height when there is a floodplain. So it's not directly a digital elevation model estimation, it's just the elevation of water above an ellipsoid. And then we have to use the digital elevation height to model to retrieve the height. But it's a common, I would say, activity using altimetry on land. So I think it's something we discussed a little bit some weeks ago when we have this dataset meeting. But for that, we need to maybe further and extend the discussion and see on which use case we can have this interests.
And just to confirm, Claire, this is limited to a long track, huh? Or in terms of spatial?
Yeah. You mean the observation is below the track, is in the footprint of the altimeter. So if we use the classical mission with the low resolution mode, it will be a diameter, a circle footprint. And if we use the fully focus or the SAR altimetry, we'll have a rectangular footprint. So the resolution, spatial resolution along the track will be better.
Yep.
So yeah, really very valuable for exploring this usage for floodplain observation and estimation of water height.
Okay, yeah. So we might go back to, I might have missed a little bit the point and our previous discussion. So
yeah, we mentioned it only once. Maybe it was much more focused on the coast.
We were always focused on the coast and trying to get as close to the coast, and the coast contamination was always a bad thing. So I think we are looking on the other side. But indeed, this could be interesting. I'm not so sure if it's enough to derive a digital elevation model in terms of vulnerability, but maybe to double check, to validate some things, it could be interesting. So we need to understand better how it can be used, because it's for sure limited in terms of spatial resolution. It's quite limited. Okay, thanks. I'm not sure. I don't see any more questions here. So let's just I got an answer from Santiago. So yes, let's keep on connecting. Like I said, Tanya has already provided in the chat the links for our social media accounts for the project. In the coming days, probably already, we'll have our official website being launched. So also a lot of information will be provided there, updated news always when we have. And in the end, I mean, in 1 year from now, there will also be a link to the products there, a very easy way to explore the results of the project, not only the data, but also the analysis. So let's really keep connected. And again, thanks very much for the Air Center. Once again, you guys proved that the networking is the key. We need to be better on this. We need to get, in my opinion, we need to get better. We shouldn't have so much people working in parallel activities. We should really rely on each other and work together. And I think Air Center is key in that perspective. So they are the main focus point for communication in EOatSEE. So anything that you want, they are the first responders, let's say, as we are talking about coastal risks. Air Center are the first responder if in case anyone has a very urgent matter. So yes, and they will convey the information for us, and we'll be very happy to communicate and connect to you. Jose, you wanna say a few words, or close?
You said it all. You can close it. Thank you so much for this opportunity. Thank you for everybody. In total, we had more than 250 registrations. I mean, lots of people watching on YouTube as well. More than 80 views. I mean, so in total, we had more than 200 in total during the day. It was very interesting. Yeah.
Excellent. Yeah, excellent. This was quite interesting. And I think this is only the start, because now we have the recording, we have the mail coming up. So share among your networks, your own networks. We are all about building a big community. I think this can be the start of a very interesting community, combining people that don't usually talk, the numerical modelers with the Earth observation, and sometimes these people are a bit far away, and especially the ones that can provide the requirements, the scientists that are interested in the processes, and the early adopters that actually are impacted by these storms and these events. So that's really the whole community that we have to build. So thank you all for coming. I'm very, very satisfied with the results today. I think we have a good roadmap both for the project and for after the project, and we also have a good starting point for building such a community, which I think is key for the success of EOatSEE. So thank you all. Hope you all had a good workshop and a great end of the day for you.
Thanks for organizing, guys.
Thank you so much for everything. Yeah.
It was silent, but we all listened.
For sure. Thanks for the partners for keeping up with me and Pedro, with both Pedros for the whole day.
Sure.
Yeah.
Bye-bye.
Bye-bye. Thank you.
Bye-bye. Thank you all.
Goodbye. Thank you.